All right, guys, can I see the screen? Can you see the screen?
Yes, sir.
Yes, sir.
I can hear me. All right. Tessie, I was calling you. I wasn't getting through.
Sir, having some connection issue, so my microphone was taking a while.
Again? You finished? Oh, okay. Please, yeah, man. Can I close it? Yeah, please, thanks. Oh, you have some connection issues.
Yes, sir. My
All right.
microphone was taking a while to connect.
All right. So your pre-maths exam is Thursday, right?
Yes, sir.
All right. So what I plan to do is do a whole day tomorrow on pre-maths. A series of small sessions. Tomorrow for the whole day. So do like a 2 hour, take a short break, do a 2 hour, take a short break, do a 2 hour, and so on. Right? And then on Thursday, I plan to do the same thing with admins. All right. So that is the plan for tomorrow and Thursday. All right. So I'm just gonna work through this one for Christopher, and then you can take it away.
Sir, this is number 3.
Yeah, man, I know this is number 3. I know you want this. I know I just found the paper. I was just searching for the paper, so I just found the paper. So I'm not doing this. I'm just right. So I know you want number 4B here, right?
Yes, sir.
And 4C. All right. So for this, I have to bring up a blank sheet to work on. So let me start by doing. Let's bring up another paper and just switch across. Let me find it over here, a clean one. 2013. All right, so I can put over here now. Well, maybe I think I should keep the question on the right and work on the left. So I'm going to make this into a blank sheet. All right, guys. So this question is a tricks question, right? You know, I can't understand why you guys have problem with tricks. I just can't understand it. God, this tricks question was a standard tricks question. There is absolutely nothing to it. It's pretty standard. They give you 2 cos squared theta plus 3 sine theta equals 0. And you're solving this for angles less than or equal to 360, greater than or equal to 0. Now look here. This is standard enough. So this thing right here, so can be expressed in terms of the square of that thing there, so. That is it, enough. Because the cos squared right here is the same as 1 minus sine squared theta. And so you form a quadratic in sine. That is all, you know. So 2 times this is 2 times this. So the thing in blue right here becomes 2 times 1, which is 2, minus 2 sine squared theta. That's what the thing in blue becomes, because the cos part of it is equal to that. And then you add back the 3 sine theta equals 0. So you know, solving a quadratic in sine, I want my square term to be positive. So I'm going to multiply it through by a negative 1. Or I could say I transpose everything over onto that side of the equation. Same thing. So when I multiply it through by a negative 1, because I want my square term to be positive. Quadratics are easier to handle when the square term is positive. This becomes a positive 2 sine squared. 2 sine squared theta. This becomes a negative minus 3 sine theta. This becomes a negative 2. Negative 2 equals 0. That is not a quadratic. It is just like 2x squared minus 3x minus 2 equals 0. Just that instead of x, we have sine theta. That is all. So we're doing the same thing. It becomes a quadratic in sign. I'm not going to change it. Some teachers will change it. I'm not going to change it. I'm going to factorize this. And it can be factorized because you can see that this is a prime number and that's a prime number. So all the factors of this, you factorize it just as you would with an x. It's 2 sine theta, sine theta. Now to get the far product and the near product difference, I want to know is the difference because that's a minus. To be 3. I have to put the factor 2 of this factor here to get the 4, the 4x, or the 4 sine theta far product. And then the 1 here to get the near product 1 sine theta. 4 sine theta, 1 sine theta. The difference is this middle term, 3 sine theta. You're going to make the far one, the larger one, negative because the middle term is negative. So make the larger one negative. So make the larger one, which is the 4 sine theta negative out here, and the near one positive. And those are your 2 factors. And you put them equals 0. Then you have this equals 0. So if this equals 0, then it means that the sine theta is equal to negative 1 over 2. Or if this equals 0, then you're having sine theta equals 2. But remember, the trig function sine and cos cannot be more than 1 or less than negative 1. So this is not valid. Sine theta has to be a value less than or equal to 1, greater than or equal to negative 1. This is 2. So this is not valid. This is not valid. So this is not valid. So there's no solution for this. This is not valid. So you're only solving this. And look here. If sine of an angle equals negative a half, the angle has to be 270 degrees. Only 270 degrees within the range of 0 to 2 pi is this. That is stuff that you can know. The more things you know, the easier questions are to do. But let's say you don't know that, and you're following the process of solving this or finding the angles for this. What you would do is draw your quadrant diagram. I'm telling you, I know that the only angle is 270 degrees, because only the sine of 270 degrees within the range 0 to 360 is a half, negative a half. But if you didn't know, what you would do, you would draw your quadrant diagram for this, and you would mark where sine is negative, sine of an angle is negative here and there. Then you would want the principal angle that will give you a half. I remember you're taking the positive of this. The principal angle, which is alpha, will be sine to the minus 1 of the positive of this. Always a positive. So you want the principal acute angle, so you put a half. The quadrant will work out itself. Or the angle will work out itself based on the quadrant that you have checked, that you have marked. So sine to minus 1 of a half is 90 degrees. Again, stuff that you should know. Sine of 90 degrees. No, it's 30. You know, so I make a mistake. I've been talking rubbish. This is not negative 1, it's actually a half. Been talking rubbish. My brain was thinking of negative 1. So it's actually a half that is there. So it's 30 degrees we're working with. All right, so it's 30 degrees. I caught myself, no problem. So the alpha is actually 30 degrees. My brain was thinking negative 1, even though it's a half there. All right, so this is 30 degrees. Sine to minus 1 of half is 30 degrees. All right, so that is that. And then now what the equivalence of 30 degrees in this quadrant and this quadrant. So this quadrant, remember, because we're working in degrees, this quadrant is 360 minus the alpha, and this quadrant is 180 plus the alpha, 180 degrees plus the alpha. And those are the 2 quadrants where my answers will lie. And so my angle theta in this quadrant that I've ticked will be 180 degrees plus 30 degrees. And this quadrant will be 360 degrees minus 360 degrees minus the 30 degrees. And so theta is going to be 210 right here. And this one is going to be 330. 330. I was thinking of negative 1 a while ago when I was talking about that with the 270. All the sine of 270 is negative 1. All right, but that is it. My brain was just seeing the negative 1. That's what happened there, but no problem. That is the solution. Understand that? Understand that?
Yes, sir.
Now watch me. They could have also given you, instead of the cos squared and the sine squared, could have switched them around, and give you this, and it will be the same approach. So it could have been something like this, but they give it a sine squared instead with the cos. So it could have been 2 sine squared theta plus 3 cos theta equals 0. Could have been that as well, because this is a cos. You want the square that this can be expressed in, which is what? 1 minus cos squared. This can be expressed in 1 minus cos squared theta. You have to know that. You have to know that sine squared theta is 1 minus cos squared theta, and also cos squared theta is 1 minus sine squared theta. And going even further, for the proof questions, and this goes for the pure math students as well, you have to know that this can be expressed as the difference of 2 squares. So further, it can be 1 minus cos theta times 1 plus cos theta. And this one down here, so remember, sine squared can be expressed as the difference of 2 squares for cos, in cos. And this sine squared also, if you express this as the difference of 2 squared, it is 1 minus sine theta, 1 plus sine theta. So have to remember that this can be expressed in this. So when you're doing a proof, for example, you see any one of these in it, you should be thinking of that. If you see any one of these in the proof, you should be thinking of that. All right? You have to remember these things. The more things you know, the better. So that's how this question would start out, by changing this to the square and form a quadratic in cos. So if I were to actually follow through, let me take these off. If I were to follow through, we're doing this one, since I wrote it on the screen. Let's follow through with it and see what we'll get. Right? Then this is 2 times this. Would simply become 2 minus 2 cos squared theta plus 3 cos theta equals 0. That's a similar solution, And then again, I want my square term to be positive. So same thing again, I'm going to multiply through by -1, or I could transpose everything over onto that side, get the square term positive. So this is going to become 2 cos squared, 2 cos squared theta. This is going to become minus 3 cos theta. And this 2 is going to become -2 equals 0. Same thing. It becomes a quadratic, but this time it's a quadratic in cos. So you factorize it again. This will become 2 cos theta, cos theta. You're still going to have the 2 here and the 1 here, factors of this. And again, this, the larger product must have the same sign as that. So you're going to put the minus here and the plus there. Same thing again. If this one equals 0, then it means that cos theta is equal to -half. This one equals 0, then to mean that the cos theta equals 2. But just like the sine, the cos cannot be greater than 1 or less than -1. Cos theta has to be less than 1 or greater than -1. So this is not valid. It's almost like a mirror image of what we just did. That thing is not valid. So we're really only solving this. So we need a quadrant diagram for this now, for this solution, to get that solution. So draw the quadrant diagram. I'm marking where cos is negative. No, cos is positive here and here. That's not where we want. We want where it is negative. It is negative here and there. So our angle is going to be in these 2 quadrants now. All right, let me shift this over a little bit. All right, then what is the principal angle? The principal acute angle. Again, let me shift this over to the right. Again, my principal acute angle alpha is going to be cos to the -1 of the positive of this. Always is of the positive of this, which is a half. This time we're working with 60 degrees, but a cos of 60 degrees is a half. So alpha becomes 60 degrees. If you're working in radians, it would have been pi by 3. If you're working in radians, all right, it would have been pi by 3. But this now, you want the equivalent angle here and here to the 60. All right, what is this quadrant? This quadrant up here is always 180 degrees minus the alpha. But if it was radiant, it would be pi minus alpha. And this quadrant here is 180 degrees plus alpha. If it was radiant, it would be pi plus alpha, which is degrees. This question is in degrees. All right, so one equivalent of those now. So therefore, my theta that I want is telling me what my angle, what my answer is going to be, where I've ticked. That's where the answer is going to be, where the cos is negative in those two quadrants. So my theta is going to be, for this one, it's going to be 180 degrees minus the alpha, which is 60 degrees. And this quadrant is going to be 180 degrees plus the alpha, which is 60 degrees. So those are my two angles for this one. This is 120 degrees, and this would have been 240 degrees. So those would be my answers if it was the other way around. All right. You good with that so far? That's okay?
Yes, sir.
All right. So let's do the next question now. The next question right here. So the next question right here gives us, let me make this a little wider. So it gives us, it tells us that tan is equal to a half, tan of that compound angle. And in that compound angle, the tan theta is 3. And I want us to use an appropriate compound angle, all right, formula to find the acute angle alpha. So we need the compound angle for this. You have to just know the trig identities. What is the expansion of a tan component? Let's set it up. The tan of theta minus alpha, they tell us is equal to a half. And within that, the tan theta within that is equal to 3. So we're going to expand this compound angle first, so we can separate the tan theta and the tan alpha. So we're going to expand this compound angle. When you expand that compound angle for tan, what you're going to get? This side. This side is going to become tan theta. Since it's a minus, I'm going to have minus tan alpha divided by 1. Since it's a minus, this under here becomes a plus tan theta, tan alpha. If you know these things in your head, it's a lot easier. That is equal to half. If you don't know this expansion in your head, then you have to go for the formula sheet. Let me see if the formula sheet is here on this paper. All right, see here, you have to go to the formula sheet right here for the compound angle tan. So you see, when it's a minus, we have, let's look at it. When it's a minus, we have the expansion. Then you have a minus up here, see there? When this is a minus, you have a minus up here, the one at the bottom, and a plus down here, the one at the bottom. So I'm marking the one at the bottom. The minus is one applicable now. The sign at the bottom of this plus or minus. One at the bottom, the minus, the one at the bottom here, and the one. So it's minus, minus, and up plus over there. So see there? All right? Minus, minus, plus under here. That is it. If you don't know the identity, you have to depend on the formula sheet. It's better we just know these things in the head. But if you don't know, you have to just use the formula sheet, guys. So I'm going to finish working this out now. Now remember that the tan theta is 3. So it means that this is 3 and this is 3. So I can substitute them right away and get that equation in tan alpha alone. So this then is going to become 3 minus tan of alpha. This is the 3 right here. Over 1 plus, this also is 3. So I'm getting 3 tan alpha here. And that is all equal to half. And I'm solving this now. So I want to make tan alpha the subject. Remember, we're solving a Triggs equation, you know, whether that is in sine, cos, or tan. We want to bring it all the way down to tan of an angle equal a value. Or sine of an angle equal a value. Or cos of an angle equal a value. That's, you know, no matter how the equation set up, you want to reduce it down to look like that. And then you, when you reduce it down to like, you can draw your quadrant diagram and tick the quadrant that you want based on this value, whether it's positive or negative. Right? So I want to get this equation right now, this equation. I want to get it down to look like the tan one. just as it's alpha. That's what my aim is, right? To make tan alpha the subject. So to do that, you can't have them dividing each other. You have to separate them out, multiply it out, multiply this out into separate terms, group the terms in tan alpha on one side, and then everything is on the other side to make tan alpha the subject. So this is transposition now. I'm going to take this denominator and multiply it up the top there. And I'm going to take this 2 and multiply it up the top there to get rid of the fractions. So watch it now. I take the 2 first and multiply it up here. So I'm going to get 6 minus 2 tan alpha equals, take this now and multiply it up here with the 1. So it's going to stay as it is. 1 plus 3 tan of alpha. I'm going to take this, let's go to tan alpha on this side, keep it positive, right? So I'm going to take this and bring it over this side, and it becomes 5 tan alpha on the right side. So I get 5 tan alpha on the right side. Take this 6 and bring it over here and subtract from the 1, from the 6. So I get 6 minus this one, give me 5. So if 5 equals 5 tan alpha, then tan alpha equals 1. You can divide by the 5. Tan alpha equals 1. So tan alpha equals 1. And you have to know that at 45 degrees. You absolutely must know that the tan of alpha is 45 degrees. I don't have to put acute angle. You must know that the tan of 45 degrees is 1. There are certain angles that you must know. You just have to know them because they just come regular. You need to know the sine, cos, and tan for 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 360 degrees. So 0, 30, 45, 60, 90, 180, 360, and then multiples of those. You need to know the sine, cos, and tan for those angles in your head. If you don't know it at this stage, you just have to use a calculator. So for this one, I don't want the acute angle. You know. All they want is the acute angle. They don't want everything. They only want the acute angle that alpha is. So I can do here, because I only want the acute angle, I could do alpha equals tan to the minus 1 of 1, and it's going to be 45 degrees for sure. That is it. I don't need to draw on a quadrant. If I wanted all the angles that alpha could be, when I reach here, I would have to draw the quadrant diagram and take here where tan is positive and here where tan is positive. Then my principal angle would have been 45 degrees, but this quadrant would have been 180 degrees plus 45 degrees if they did not only specify acute angle. All right, but this over here is not valid now for this question. That is it. Okay with that? Okay with that, Ibams?
Yes, sir.
All right, good. All right, so which other question you want now on this paper?
Number seven. That was the probability question.
Oh, probability?
Yeah.
You want the whole, this one, you want the whole question?
Mostly just the first part with the tree diagram.
Okay, all right, cool. Let's see. All right. So this question says, of the persons buying petrol at a service station, 40% are female. Okay, so this is a 40%. So I've started it for you. So 40% is 0.4 probability are female. So this is a female leg. All right, and 40% are female. So the rest of them are male. So I can put 0.6 on the tree here. This becomes 0.6. So the total probability has to be 1. You know? So if you have 40% up here, then you have 60% down here, which is 0.6. So I can put 0.6 on the tree diagram right here. All right, to start. Then it says, of the females. So of the females now. So you reach into the female now. Of the females, 30%. See here? 30% pay for the petrol in cash. So this is the cash, and it's 30%. So if 30% pay cash, Then the 70% don't pay cash. I'm going to put 30% here, which is 0.3. And so this is 0.7 who don't pay cash. But the total probability again must be 1. All right. Then it says of the males, so of the males now, 65% pay theirs in cash, so the 65 there. So the rest of them must pay other. And so that needs a 0.35 to make it 1. So that is your completed tree diagram. All right. I'm sure they're gonna ask you to do that. Let me see. All right. So that is it. So it says complete, copy and complete the following tree diagram by putting in all the missing probabilities to show this information. So that is it. Understand that so far?
Yes, sir.
All right, good. And down here, so it says, what is the probability that a company, that a customer pays cash? So paying cash is here or here. It's an or situation, you know. It's either you're a female paying cash or you're a male paying cash. So it's one or the other. And when it's an or situation, you add the probabilities. So what is the probability of paying cash and be a female up here? You multiply these values. So you're going to multiply this times this. All right, let's stick to the two decimal place. Right. So the probability for each line up here, for this one is going to be this times this. What I work out is 0.4 times 0.2, which is 0.12. This is going to be 0.12. You understand? I'm going to get the 0.12. I multiply them, right? So you're a female and you pay cash. So you could say FC, probability of FC. That's what this is. Probability of being a female and pay cash is you multiply these two values. 0.4 times 0.3, so 0.12. All right, let me get the calculator. Add up some of these just to make sure. But that has to be 0.12. All right, it has to be 0.12. So see, is 0.4 times 0.3, 0.12. And then you do the same thing here. Female and don't pay cash. So probability of being a female, we use other method of payment, you multiply this times this. So that is 0.28. 0.4 times 0.7, 0.4 times 0.7, 0. No, extra 0 on this. So 0.4, 0.28. So this is 0.28. I'm just doing all of them. And then this times this, 0.6 times 0.65. So the male and pay cash. 0.6 times 0.65. This is 0.39. So probability of being a male and pay cash is 0.39. And then now here the probability of being a male where you don't pay cash is male and don't pay cash is this times this one, which then is 0.6 times 0.35. That's 0.21. 0.21. So those are the probabilities. Now, if you pay cash, is either you're a female and pay cash or you're male and pay cash. So this one becomes equal to the probability of cash against the probability of paying cash equals the probability of being a female who pays cash, or which is plus the probability of being a male who pays cash. So you're adding those two probabilities, you're adding this and this. So let's add them, which is a 0.12 plus 0.39. That's 0.51. 0.51. 0.51. All right, so far so good? So far so good? Hey, Banks? Hello? Come on. Hello? Drop off. Hello? Hey, Banks. Banks, drop off. Not here. Let me just continue still. Then this one says, determine which is more likely. Which of these is more likely event? Event T or event V? Which one is more likely? So the one that is more likely is the one that will have the higher probability, right? So a customer is female, given that she paid cash. So basically then, is to pay cash is this, you know. So I know out of this, out of paying cash, what's the probability of getting a female? So basically then, is this out of this? That's what this line means, you know. She's a female, right? Probability, given that she's a female. Oh, the customer is female, given that she paid the petrol with cash. Right? So basically this amount, this amount, the female who paid cash out of the total people who paid cash. That's what this probability is asking, you know. Right? Given event T, customer is female, right? That is it, female who paid cash. Given that the person paid cash, given that the petrol was paid with cash. So the petrol was paid with cash. This is like your sample space now. And out of those persons who paid cash, these are the ones who paid cash and are female. So it's this amount out of this. So this probability would work out to. This probability will work out to 0.21. This one will be 0. I want the space. Let me bring it up on this side. I need the calculator. Let me leave it here. So let's make it smaller. So this would be this one would work out to be the 0. What was it again? 0.12, 0.12 out of all who paid cash, 0.51. I'll work out that value. All right, so that would be 0.12 divided by 0.51. That would be 0.2. It says 0.24. 0.24. Then this one now, this is event E, you know. And then this one now, you know, event T. Then this one now is a male customer does not pay with cash. All right. A male customer does not pay with cash. Now, what are the male customers who don't pay cash? A male customer does not pay the petrol with cash. This, you know, this. The male and don't pay cash. A male customer does not pay for petrol with cash. That is it, 0.21. So this is 0.21. 0.21. So which one is greater? Event E is greater probability. So the answer for this is event T, not E. Event T is greater. So probability is greater for event T. More likely. So T is more likely. T is more likely to happen. Right? Because it has a higher probability of happening. All right. So you say they want that one. Ibang Seba. All of a sudden, I'm seeing him, but I'm not hearing him. I'm seeing him, but I'm not hearing him. All right. All right, let me do this one down here for instance, just in case, because you did ask me to do this question. And then I'm going to focus on the pyramids. All right, now I'm telling you guys, tomorrow, I plan to have an entire day of pyramids. I'm going to try and start in the morning. I'll send out the link and let you know. I'm going to try and see if I can do some 2 hours. That's like 2 hours, take a short break, 2 hours, take a short for the entire day tomorrow, because I know the exam is Thursday. And the approach I want to use is that you guys bring your questions that you want me to explain. All right. I sent the 2023 paper in the group this morning, and I also sent you a link to a video that I did last year of it. Last year paper was really something else, I can tell you. I had some really nice questions on it. I don't know what's going to be this year. I'm telling you, I see other people doing solutions for the last year paper, and some of their solutions are incorrect. Right? The video that I sent you I made one or two mistakes on it, but they are just like calculation mistakes. Right? Like for example, there was a question where I had on one line 19, and in the next line I just for whatever reason put 18. Right? And then the answer came out to the wrong value. Simple stuff like that. Right? That's the only thing. But I've seen questions on it where people have solutions online and error of principle, not calculation error like that one that I just explained to you. So I advise you to watch that video for the questions from last year. I sent it in the group, the 2023 paper last year. The questions on it were like, I don't know. They're just uncharacteristic, to be honest. Right? But not that they're difficult, but they're just uncharacteristic. So I'd advise you to take a look at those solutions. But then come tomorrow, bring your questions. Just easier if you bring the questions you want me to explain. I will just explain it as much as possible without actually like teaching everything from scratch. Just that while I'm explaining it, there's something you don't understand, you ask me. And if I need to go a little bit deeper into the theory, then I will do that. Right? All right, look at this question. I'm just doing this one and then we're going to focus on pyramids. All right. All right. So this one says mark obtained by 30 students in an English exam are given. So there are 30 students obtaining these marks in an exam. It says state one advantage of using a stem and leaf diagram versus a box and whisker plot. All right. So the stem and leaf is the one that we put the data like this. You have the stem figures over here, and you have the leaf over here. All right. And the box and whisker plot now is when you set up the box and whisker plot and so on. What is the advantage of the stem and leaf diagram? One advantage of a stem and leaf diagram is that all of this data can be compressed and shown on a stem and leaf diagram in a compact way. What do I mean? Because remember, the stem values are not repeated. The stem values are not repeated. All right. And again, it kind of gives a kind of general look of how the shape of the data is when you write it. The disadvantage with the box and whisker plot is that it is basically only showing 4 specific values. It's showing the lowest value, it's showing the first quartile, it's showing the second quartile, it shows the upper quartile, and it shows the largest value. And these quartiles sometimes are not even specific data values. Some of them are calculated values. All right. So this over here would have the largest value. So that is one of the disadvantages of using a box and whisker plot, because it don't show the actual data. At least the stem and leaf diagram, you can pull out actual values from the stem and leaf diagram. You cannot pull out actual values from the box and whisker plot. Only these 5 values you can pull out from it. All right. So that's what I would say is the advantage of the stem and leaf. It says construct the stem and leaf diagram. All right. Construct a stem and leaf diagram for this. So basically you're going to put a stem side, and you look at the tens in these values, right? So what's the lowest one? The lowest one, and I don't like that it is nothing in ascending order. So you're gonna have to write down each one and eliminate. So the lowest value looks like a 4, like a 40. Looks like it starts at a 40. Then you have 50s, 60s, 70s, 80s, and 90s. There are no 3 digits there. All right. So I'm gonna fill in these now. So the 58, I'm gonna put 12. That's not even the lowest value. That's what I don't like about this question. The values are all over the place. All right, the first one here is a 50. I see a 50 right here. All right, so I'm going to put a 5 right here, a 0 for the 50. Are there another 50s? Here's another 50. Put another 0 here. I'm just doing the 50s now, right? So a 51 right here, another 51 right there. So I'm going to put a 1 and a 1. Don't like this question at all. I have to be searching. Easier I just put the values in ascending order for you. 52s, are there any 52s? No, not in 52s, 53s. Here's a 53. Let's put a 3 right here. 54, 55, not seeing any 55. I said 56 here and here. 56 and 56. 57. Don't see any 57. 58. All right, so 58 right here. 58. I'm gonna put that 8 right here. 58. And there's another 58. 58. Those are my 50s, I think. I find another one, I have to squeeze it in there, right? Let's do the 40s. So see a 40 here, 40, another 40, see a 41, here's a 41, 41, another 40s, see a 45 on this line, 45, 45, and I think those are my 40s. So I do my 40s and my 50s. Let's do my 60s now. So any 60, I don't see any 60. It's the lowest 60 as far as 63 and 63, two of them. 63 and 63. Another 60s. Yes, I see a 69. All right, I see a 66 right here, 66. And then there's a 69 right here, 69. All right, I don't see another 60s. I'm a 70s now. All right, so 70s, lowest 70 I'm seeing is this 71 right here. No, 72. So 72, then 70, 74 is the next one right here. 74, 74. I see a 75 and another 75. So 75 and 75. 76. I see a 76 right here. 76. Another 70s. No. Don't see another 70s. Them are 80s now. So 80s. The lowest 80 I'm seeing is this one right here. That's 80. 80. And I see a 81. I left off a 66 and I see another 81. I'm seeing a 66 now. So 81. I'm gonna put it in afterwards. 81, right? 80s, 80s, 80s. So I say 83, 83. Then I see a 85. I just think this question is unreasonable. 85. Somebody have to beat an exam, searching for values and putting them in ascending order. Imagine that. In an exam. They never 89 right here. 89. All right, now come to my 90s. But leave out a 66 and so that's what you have to do. So my 90s now just a 92, a 94, and this 99, and this 66 was left out. I'm gonna squeeze it inside here. So I'm gonna just shift these over, put another 60 here, put another 8 over there. And that is my box and with my stem and leaf diagram. So I'm gonna put this as my stem. That's my leaf. You must never complete the stem and leaf diagram without putting a key. So we put a key that says, for example, 6 line 3. 6 line 3 means 6 line 3 means 63. So I give them one example. All right, so I've done that part. Next part says we have to determine the median mark. So the median mark is a mark in the middle. Know that it's in ascending order. It's the one that's in the middle. So how many values are there? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 3 is 30. Well, they did tell us it's 30. 30. All right. So since the median is 30, since the total value is 30, the data will be divided 15 and 15. Half and half, 15 and 15. So the median is going to be the last value of the 15 and the first of the second 15. It's going to average them. So it's going to be the 15th value plus the 16th value divided by 2. That's what the median is going to be. Because it's 60 values, 30 values divided 15 and 15. So the median will be the last of the first half of the data and the first of the second half of the data. They want the midpoint of you want the value in the middle of this data. All right, so the 15th value plus the 16th value divided by 2. So the 15th value, I'm going to count it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a 15 value and a 16 value, averaging them. All right, so the Q2, which is a median, becomes 63. For the first 3 there, 63 plus 66 divided by 2. Divided by 2. So you're averaging the 9, so that's 64.5. That's work out to 64.5. That's what that is. What I go to that? Well, really, it's the banks who want this.
Yes, sir. I understand.
All right. All right. So next one, calculate the semi-interquartile range. So get the semi-interquartile range now. You need the quarters, right? So remember, the bottom half is 15 values and the top half is 15 values. So these 15 values are going to divide it 7 and 7. And the median is going to be in the middle. So the median of this bottom half is the 8th value. So Q1 is the 8th value this way. So let's look at it. Q1 is going to be the 8th value this way, the 8th value is Q1. And the 8th value this way on the back is Q3. All right, so that is it. We're doing the middle of 15 value is the 8th value. The middle of 15 value is the 8th value from either side. So the 8th value from the front is Q1. So 1, 2, 3, 4, 5, 6, 7, 8. This value right here is Q1. 1, 2, 3, 4, 5, 6, 7, 8. So that first 3 there is Q1. This is Q1. And then we're doing 8 values from the back. So it's 1, 2, 3, 4, 5, 6, 7, 8. That's the 8th value from the back. This value is Q3. So the interquartile range, now the Q, based on this, the Q1 is 53. And the Q3 is 80. So doing 80 minus 53. So the interquartile range for the semi, the one in a semi. So the semi-interquartile range is half the interquartile range. So the semi-interquartile range is the Q3 minus Q1 over 2 because it is the interquartile range over 2. So it becomes the 80 minus 53, 80 minus 53 over 2. That becomes your semi-interquartile, whatever that works out to be. It says 2 students are chosen at random from the class. The probability that both scored, or 2 students are selected at random from the class. Oh, there's a thing there now. 2 students are selected at random from the class. Determine the probability that both scored less than 50 on the exam. All right, it's a question that kind of tricky now. 2 students are selecting 2 students. I want the probability that both of them scored less than 50. All right, we'll set this up now. So like you select the first one and you score less than 50, and you have to select the second one who also score less than 50. All right, so after you take out the first one, you have less student left. So look at it now. So probability of a first 50. So call it first who score less than 50. I just call it first and second, right? Probability of a first and a second who score less than 50, and we take them out and I replace them. That becomes the probability of taking out the first one times the probability of taken out the second one who scored less than 50. So firstly, how many persons initially score less than 50? I take out one of them. So less than 50, these are 50, you know. So initially less than 50 are just these 3 persons, right? Less than 50, that's what it says, who scored less than 50. So it's a determine the probability. 2 students are chosen at random. Determine the probability that both score less than 50. So you want the first one to score less than 50, and the second one must score less than 50. So I'm going to set up this way. So take out the first one who score less than 50. How much of them score less than 50 initially? 3 of them. Because this is 15. I want less than 50. Both score less than 50. So it's 3 out of 100 first. 3 out of 30 first. So that's 3 out of 30. 3 out of 30. And then you also want 2 out of 29 left. After I take out that one, then I'm gone outside. Right? You take out one already. And to get a second one, now you're going to have to get 2 out of the 29 left. And that is going to be a probability of getting 2 students who scored it. That's this times that. So it becomes 6 over 30 times 29. 6 over 30 times 29. Where is it? So you get a fraction 6 over 30 times 29. One leaves as a fraction. So it becomes 1 over 145. 1 over 145. 1 over 145. That's it. You good now, boss? Hello?
Yes, sir. Yes, sir.
All right, that is it. All right, I do some pure maths now because I'm gonna spend because the pure maths exam coming first. You have anything else, Ibang, before you go?
No, sir. I'm fine.
All right. Giovanni, I see you coming online now. We're gonna do a session. We're gonna do a whole day tomorrow with the pure maths, and then we're gonna do a whole day Thursday with the hard maths. So make sure when you come, right? Make sure when you come Thursday, you have all the questions we are meant to do ready. Thursday for the whole day Thursday.
Sir, what time on Thursday? Come up exam.
You have exam Thursday?
Yeah.
You have exam tomorrow? You have exam tomorrow?
No, I have no exam tomorrow.
Really? Oh Lord, exam set up. What about the permanent students? You have exam tomorrow? I think some people have bio tomorrow.
Yes, sir.
Shade, you have exam tomorrow, right?
Yes, sir.
Right. So it's the day after that I want to spend the day after tomorrow. Well, tomorrow after the exam. So what time exam is tomorrow, Shade?
Start 1.
Start at 1.
Yeah.
So you're gonna have to be in the afternoon. You can spend some work this evening now, you know. So you're gonna have to be in the afternoon. What time is your exam Thursday, Giovanni?
1 o'clock, sir.
Okay, so we're gonna have to juggle it. We're gonna have to kind of juggle it. The important thing is for you to just let me know which questions from the past papers you want to. That is where we're at now.
All right.
Which questions on the past papers. What about you, Kerona?
There, what was the question?
When is your next exam before the ADMATs?
Like CXC?
Yeah.
Sir, me not 10th grade, man, I'll do that till next year.
Oh, you're not 10th grade, I do ADMATs. Oh, so you're good. So you can work, man. All right, so you're good, we'll go. All right, remember now, I want you guys to tell me what questions you want me to explain. All right, so I just did a couple of ADMATs questions. I'm going to take some pure maths questions now, and they will just swing back around. So I could juggle it. All right, so Shade, you have exam tomorrow?
Yes, sir.
All right, so let me take your questions first. About Tessima, you have exam tomorrow, Tessima?
Sir?
You have
Sir?
an exam tomorrow?
No, sir.
All right. What about you, Nathan? You have an exam tomorrow?
No, sir.
Nathan?
You hear me?
Not here. You have exam tomorrow?
No, sir.
All right. So based on that, make we try let go Shadi, you know. We just take Shadi's questions and leave her and she go study her bio for tomorrow. So let me take any question you have, Shadi, that you want me to just go through quickly in this maths. Because we're gonna after your exam tomorrow, you can fall in back. Because what might happen is that we might actually start before you come on tomorrow. Right? But I'll take whatever questions you have now so that you can just clear what you want me to answer for you now. And then you can, you know, go and do your bio if you feel so inclined. If you're good at the bio like that and you want to stay, no problem. But if you want to go and do some work on your bio in preparation for tomorrow and it's 1 o'clock, you can let me know. I'm prepared to do some.
So I know
work
the
this
bio
evening.
like that.
Oh, so you need to do your bio. So are there any questions you want me to do now? Because as I'm saying, chances are
Yes,
tomorrow
sir.
you come. All right, so tell me which one. Let's go.
So it's the 2013 and
2013.
after 2012 and 2023 tomorrow. But the
Hold on.
2013,
I'm going to go to the 2013 first. I'm open the 2013 paper. Hold on. I'm open the 2013. Hold on a second. Hold on. All right. All right. 2013, I say. 2013.
yes, sir.
All right. Let's do this. 2013. All right. 2013. Which one? Which question? Which one you want? Which question, Shadi?
Oh, so
Huh?
3B.
Question 3B. I think Ibang's. Oh, that's advanced. Come on there. I think Ibang's the one that question there and this one. Ibang, so I get back to it here. Just get like study it. Make sure go. I think you say you wanted this question. So let me just make sure you get to go because I have exam tomorrow. Just clear off the questions that people have exam tomorrow want me to do first. Pick up one wrong paper a while ago. Paper 2, 2013. Let's clear that all the way. Question 3B. Part B. That's this one right here.
Yes, sir.
This one. Just the B part. Just the B part. This one. All right, good. That's a pretty standard question, yeah? Pretty standard. I'll deal with it. Show you we can approach a question like this. See if we approach it. It's a question like this. I tend not to use the full process that a lot of teachers use for a question like this. To convert this to that. Let me show you what I mean. Now, some teachers will basically expand out this fully and then start to equate coefficients with that expression. So it's like they say, okay, the f of theta equals 3 cos theta minus 4 sine theta. And I'm going to write this expression as r cos theta plus alpha And then expand this out and say it is actually equal to expansion of cos is cos minus sin. So let's say it is equal to r cos theta. And r is a factor, right? So expand this. Then r cos theta cos alpha minus r sin theta sin alpha if you expand it. And then they start to equate coefficients. So if you look at the coefficients of the cos theta, then you will see that the r cos alpha is 3. And if you look at the coefficients of the sin theta, then you see that the r sin alpha is 4. And then you set up the difference of 2 squares, the square both sides and all that. But all of that not necessary. That's the point. That's the point. Not necessary. It's not necessary. Give you some general rule right now. If you remember these general rules, then you'll be good to go. All right. So the general form for these expressions is this: a sin theta plus b cos theta, or it can be a sin theta minus b cos theta. That's one option. See, these start with sine. Let me make this smaller for now. Right? These start with sine. I'm going to give you the general format that you can use for the result. And the result is the same once you pick the right one for the right format. All right? That's why I do these questions. There's no need to do that big, long, expansive work. I'm telling you. Then you have the ones that start with cos. So it can be a cos theta plus b sin theta, or instead of a plus, I can have a minus. A cos theta minus b sin theta. Those are the 4 possible ways that these expressions can set up. Now, you see for these two, you start them r sine. Because the sine is first, you start them r sine theta. Like this, r sine theta. That's how them start, because you have sine first, so they start r sine. Now remember that the expansion of the compound angle for sine function, whatever sign is inside here between the values, is the same sign that comes out here when you expand it. Right? Whatever sign is between the values here is the same sign that comes out in expanded form. So you see, if it's this we have, so I'm going to put it now. Let me shift this one up for this one directly. So if it's a plus we have right here, so let me put a plus in between there, so I'm going to put plus alpha. You see, if it's this one with a minus in between here, so start with a sine. So it starts at r sine theta. Since it's sine and expansion of sine, whatever is in the bracket, the same thing in about here. If this is a minus, then I need a minus in there. So it's minus alpha. If it's these two, no, watch this now. These two. Since it starts with a cos, once it starts with a cos, I am using r cos theta. For this one, same thing. For this one, start with a cos, so I'm using r cos theta. But the thing with cos expansion is that if there's a plus out here, inside here, when I expand it out, I get a minus in between the values. So therefore, whatever sign is in here, in the expanded form, I need the opposite sign in between there when it's cos. So this has to be minus alpha. And since this is a minus, I need the opposite sign in between here when it's cos. And so I need a plus alpha. Now you see, in all these cases, once I set up this, which match that, this, that match that, this, that match that, or this, that match that, in all of them, the r is equal to the square root of a squared plus b squared. The r value that is coming in front is equal to the square root of the a squared plus the b squared, irrespective of what is in between them now, because I have already set up to account for the sign that is between them, the plus and the minus. You see the alpha that is coming here is an acute angle. That's the first thing. It is always equal to tan to the minus 1 of the B over the A. That is it. That's all you need. Screenshot that and memorize that, and you're good to go. You have the justification for it. So I don't bother with the long, expansive work to prove it, because them results here are standard and come down to some formula. Once you set up the right one to match what you're given, that's what it is. So it's a matter of setting up the right one to match what you are given. How did I set it up? Look again. If my sine value is first, then it's R sine I am using. And once I am using R sine, whatever sign is between here is the same sign in there. Whatever sign is out here in between here, the same sign is in there. If my expanded form starts with a cos, then I'm doing R cos. But because it's cos, an expansion of cos changes the sign that is between there. If it's a plus over here, I have to put a minus in there. And if it's a minus over here, I have to put a plus inside there. And then whichever one it is, the R is equal to the square root of A squared plus B squared. And the alpha is tan to the minus 1 of B over A. Not A over B, you know. B over A. Tan to the minus 1 of B over A. It has to be B over A. The B over the A. But let me show you something now. I'll show you something now, before I move on to this question. Let me show you something now. I have to be smart. What I've noticed in recent times is that they will forever give you, for example, give you this. I'm going to use these same values, right? They will, for example, give you this question that says, write 3 cos theta minus 4 sin theta in the form. And then put this now. Then put R sine of theta minus alpha, something like that. And give it, I'm gonna put a plus in between here, so just to keep it simple, and then give it that. That's what they do sometimes. You know. They give you this and tell us they must write that. This don't match this right now in terms of the setup. This does not match this, because my first expression is a cos, but this is a R sine. So what do I do if I'm going to write this as R sine? I have to take this and turn around the values and write it instead as. I have to take this now, you know. If I am going to, let me go back again. Hold on. If I am going to use, if I'm going to write this with the R sine, then I need the sign to be in front. So I'm going to turn this expression around and write it instead as, put the purple. I'm going to write it instead as 4 sin theta plus 3 cos theta. That's what I'm going to do. Now this now match this. It means then that my A is 4. See? If you would have one, I might use the A equals 3 and get it wrong. And my B is 3, not 4. My B is 3. Very important. Especially to get the alpha. The alpha. Then now, because I switch it around to get this, the expression that they gave me, I switch it around to get it in a format that match what they want. Because they're telling me to get R sine, you know. Then now, I know my A is 4, because I use this one. Because that is the one that matches this. Right? But this would have to be a plus now, right? Because once I do have a minus in here, this would have to be a plus because it's sign. So I'm going to put the plus. But you're going to see questions. I'm going to show you another question where they put it the other way, especially in recent times. I noticed they've been doing it. Right? This is what it would have to be. Plus. Because this is a plus and a sign, then this has to be a plus. And in that case now, my R is simply equal to the square root of 4 squared plus 3 squared, which will work out to be 5, And alpha would be tan to the minus 1 of the B which is 3 over the A which is 4. And what I normally just do when I'm doing this question, I write the formula then. So when I really write this first, let's write the formula then first, shift this over, show the formula. So I'm going to tell the examiner say A equals 4 and B equals 3, you know. Up here, so you know, in this expression, you know. And then I tell him, so the R equal now the square root of A squared plus B squared, just to give a method for doing it. I say it equal that. And I tell him, so the alpha is actually equal to tan to the minus 1 of the B over the A, show him the formula for it, and then show them equal that. And I work out this now. I always work out the acute angle for this. Because it's always going to be positive, you know. So it's going to be positive. Because the A and the B don't really care positive, no positive and the negative sign. Because we already account for the positive and the negative. We already account for the positive and the negative from the setup that we are using. So the A and the B are always positive values. So the alpha will always be an acute angle. The alpha. And you work out 10 to the minus 1. Sometimes they ask for it in degrees, sometimes they ask for it in radians. So this example here, so is asking for it in what? Radians. See here? We'll actually mess it up because look what them say. Them say 0 degrees pi by 2 radians. So this should be degrees. It should be radians, right? 0 radians to pi by 2 radians. That is it. Understand that, Shadi? And other students? This is all you need. This is all you need right here on the screen. This is all you need. You don't need a big long process.
So they won't penalize if you don't have the
No. Listen, my students who tap the Caribbean, I saw them do it. My students who have taught in the past, and then tap the Caribbean and this step on the paper, I saw them do it. You can't, the means they get full marks for it. You cannot be penalized for having advanced knowledge. It's especially if the question give you this, and you turn it around and write it so, and then tell them say A and B is that, and then tell them what R equal to in terms of A and B. That's a method. To use a formula is okay in maths. Maths is a subject riddled with formulae. So if you use a formula approach to solve a question, who are them to penalize you? They not tell you specifically what method to use to show it. They just show it. So you use a method. If you arm yourself with the knowledge of using a formula approach to do something rather than some long 5 steps process, and you arm yourself, you carry the exam with a formula in your head, who are they to penalize you for using your formula? So mathematics is a formula subject. The problem is that a lot of teachers teach this thing using the process approach, and you don't need to use the process approach. You need to understand the proper setup of the expression, and to understand the proper setup of the expression is to understand and know the expansion, the compound angles. Right? I don't have it on the sheet, but it's to understand how the compound angles work. So you know, for example, that if you expand the sine compound angle, so sine of A plus B, I'm going to put the plus or minus B, expands into sine cos sine. Sine A cos B cos sine. Cos A sine B. Sine cos sine. So I need sine B now. So it's always AB. But the expansion of a sine compound angle is sine cos sine. And you know, so for sine compound angle expansion, whatever sign is inside here, the same sign go there. So since this is a plus or minus, then this has to be a plus or minus. For the cos compound angle is the opposite with respect to what goes between here. So if I do a cos of A plus or minus B, then first thing you know, that expansion of cos is cos sine sine. Cos sine sine. So it becomes cos A cos B sine sine. Sine A sine B. That's the first thing. Cos sine. First, them values here, the A and the B in the same order out here. AB, AB. Then what do you know about the cos expansion? Whatever sign is in here, the opposite sign goes there for the cos. So since this is a plus or minus, I have to put a minus plus here. It means that when my term in here is a plus, I am using the minus. And when my term in here is a minus, I am using the plus. For the sine compound angle up here, when my sign is here in a plus, I am using still a plus. When my sign is in a minus, I am using still a minus. That's the difference. You see it here now, look over here, so now I'll make the connection. This is a sine compound angle. So when this is a plus, because this is a plus, because the plus go with the plus over here. And when this is a minus, because this is a minus. Why? Because the compound angle for sine, when there's a minus in here, is a minus out here. Then for the cos ones now, over here, for the cos ones, this is a minus in the cos one because this is a plus. Why is that? Because in the cos compound angle over here, when inside there is a plus, out here is a minus. So you see the difference. You see the difference. See? And when this is a minus over here, out here is a plus. So therefore, over here, this plus is because in between here is a minus. That is it. So if you go in the exam, arming yourself with all of these to avoid having to do a proof. The question now asks if a proof what R is in or alpha is in. It is just telling you to write in those expressions. So you don't have to go through the proof of it. It's not a proof thing. You see, express this as this. Let me tell you how to express it as it is. You understand that? But a lot of teachers feel like the students have to go through the whole thing because what? Because that is what is in the textbook. No, you don't have to do that, but it's in the textbook. Right? Learn an easy way to do it and do it that easy way. So I'm in the exam, I'm getting this. Right now, first thing I note, I'm looking at if this match this. Yes, it match it. Because the cos is first and it's R cos. This is a minus, I need the opposite sign in here. Yes, everything match up. So what am I going to do for this question? I'm in the exam room. And then give me that for the right? Come here, do it now without doing the whole proof. I'm gonna say, okay. I'm gonna say, well, the good thing about you be able to write on the exam paper, right? So I assume that this is the exam paper. F of theta equals 3 cos theta minus 4 sin theta. First thing I'm gonna tell you is that A equals 3 and B equals 4. Remember, I know the minus will be taken care of, by the one that you use, right? F of theta is going to be R cos. This is a cos. This is a cos. Good. Theta, this is a minus. I need a plus in here. Why? Because it's cos I'm doing. Alpha. The R is equal to the square root of A squared plus B squared. I'm telling him, oh, I'm getting my R. The A is 3. See the 3 there? The B is 4. See the B there? And this becomes the square root of 3 squared plus 4 squared, which works out to be 5. Then I tell them that alpha that I have here is tan to the minus 1 of the set B over the set A. I'm putting in the formula. I tell them how I get it. So I'm going to put the formula. That's the most I will do. Put them formula there, so, for my method. And tell them what A is and what B is. That's my method. That's why I teach my students to tap the Caribbean. So they get the marks for it. So this becomes tan to the minus 1, the B is 4, and the A is 3. All right? And they wrote that out to the calculator. All right? So let's do it. I'm doing the question now, so let's do it. So I'm going to work this out to the calculator. And I'm working in radians, right? This is in radians right here. So tan to the minus 1 of the 4 over the 3. All right? Tan to the minus 1 of the 4 over the 3. I'll make sure the calculator is in radians. So right now the calculator is in degrees. You can see it up there, so in degrees. I will change it to radians first. All right, it's now in radians. I'm going to do tan to the minus 1 of a fraction 4 over 3. And it is 0.927. Remember those figures, because these are common figures. 0.927. So it's 0.927. Let's shift this over. 0.927. So this becomes 0.927 radians. And then I can write my f of theta now. See here, this f of theta, I'm going to write it now. And say, put in purple. Therefore, f of theta, the r is 5 cos of theta plus alpha. And the alpha is this, plus 0.927 radians. Understand that, guys?
Yes, sir.
Good.
Yes,
All right. Then I'm asking for the maximum. The maximum is this. Why is that the maximum? Because this cos function, this cos value, this cos of an angle, cos of any angle can only be between 1 and -1. This can only go between 1 and -1. So the function is maximum when it equal 1, when this equal 1. So the maximum is 5, as 5 times 1 is 5. And it is minimum when it equal -1. So when this equal the lowest value that can be -1, you get the minimum, which is -5. Simple as that. And sometimes you ask for the value where it is maximum or minimum. So let me add in a part there. So it asks for the maximum here, but sometimes I ask for the value of theta when it is maximum. I'm show you how to do that now. So what is now? How will I do it? So part 2. Part 2a. If then I ask for the value of theta when it is maximum, what you do? Because I ask that sometimes, right? You say f of theta max, you can say it like this, is equal to 5. When is equal to 5? When the cos of the theta plus 0.927 is equal to 1. That's when it is in. Remember now, the cos of 0 is 1. So this when this angle inside here so become equal to 0. Because the cos of 0 is 1. Right? So you can say that is when the angle in here, theta plus 0.927 is equal to 0. And so it's when theta equal -0.927. They could have also asked for the minimum. They could have asked for the minimum as well. What is now for the minimum? If you had another part for the minimum, we could say f of theta min is equal to -5. -5. That is when this part equal -1. Watch this now. That is when the cos part, cos of theta plus 0.927 is equal to -1. Now the cos of what equal -1? The cos of 180 degrees, which is pi. You can test it if you want. The cos of pi. More things you know, the better. You don't have to go to the calculator. The cos of pi is -1. You want to see it? So it's when the angle equals pi. Look. Cos of pi is -1. So it's when the angle in there equals pi. So see it, you know, is this equals -1 when the angle equals pi. So that is when, i.e., when theta plus 0.927 is equal to pi, which means then it is when the theta is equal to pi minus 0.927 radians. You write that out and get the answer for when it is minimum. But look at this part now. This right here. So it's to find the minimum value of this. You know, guess and spell to find the minimum value of that. Because this value right here, it has two extremes, the f of theta. The two extremes are -5 and 5. The f of theta, look at it now. I want the minimum value of this expression right now. Right? So I'm going to try to find the minimum value of this. So some values, they call it value v equal 1/8 plus f of theta. You see the f of theta right? So it goes between 5 and -5. That's where it goes. So to find the minimum value of this, all I have to do is plug in the two extreme values of that and see what I get. I'm telling this the lowest one. This is my minimum. I'm gonna go over it when I'm done. Yeah, leave it. Thanks. That's all I need to do. Plug in the two extreme values of that and tell them the minimum one. If they want the maximum one, I give them the large one. If they want the minimum one, I give them the lowest one. That's all I need to do. I don't figure out nothing. So one value is when it's -5. So I'm gonna say when, look, watch this now. My solution for this now is this. I'm gonna test it. I'm gonna test it out in red. So when f of theta is -5, that's one extreme that f of theta can be, is -5. The v that I'm trying to work out is equal. Me just call it v, and you can call it anything you want. Don't call it nothing here, so just call it v, so I can reference it. You always go and you can reference something in math, right? Is 1/8 minus 5, which becomes a third. Okay, and one extreme value now for the v. The other way, the other extreme is when f of theta equals 5. When f of theta equals 5, the v becomes 1. This is now a positive. Hold on. Is a -5 is a plus term of vertex, right? Yeah, 8 plus 5, right? My v becomes 1/8 plus 5, which is 1/13. This is smaller than that. So that's my minimum. If you put in 0, which is a point that is a value that this pass through, which is an interesting value, like an important value, one of those uncertain values sometimes, 0. What would 0 do? Because 0 is a special kind of number now. Like, for example, 0 has no multiplicative inverse. So 0, a number like 0 can create problems sometimes. And it throw out the mathematics sometimes. Sometimes the mathematics don't work when a value becomes 0. So an interesting value that you could maybe try and there also is 0. So we could put, because 0 is within this range as well enough. So I could try 0 just to see what happens at 0, because 0 is like a special value. Sometimes just make the thing do work a different kind of way. So I'll probably try 0 as well. So, all right, just put the 0 as well as the middle of the range. Right? It's also in the middle of the range between -5 and 5. So we could say, okay, when f of theta, it can be 0 to equals 0, the v becomes 1/8. So you see, it's gotten less, but not as small as that. So that's my minimum. Therefore, minimum value of 1/8 plus f of theta is 1/13. That's my answer. Smallest value. That is it. What go to that?
Yes,
Go to that,
sir.
Miss Shadi. All right.
Yes, sir.
Remember this method now. So when I'm giving this to show the maximum or minimum, just plug in the three values in there. Whatever the range of f is, plug the smaller one in there, plug the 0 in there, and plug the larger one in there. And just tell them if it's maximum they want it, this would be the maximum. Because that number bigger than all of these, 1/3. But the denominator is the smallest. So this would be the one maximum for that expression. 1/3 is the maximum that it can be. 1/3. All right. You want to do that part here too? Say yes.
Yes, sir.
You want to? All right. Beautiful. More math equals better maths. Let's do that part as well. Is a thing. See this thing? When them say ABC is a triangle, there's a wide range of we call now. There's a wide range of we call identities connecting A, B, and C for triangles. A wide range of things that they can ask you for a triangle starting with A, B, and C. This is just one of them or two of them. This is like two of the easiest ones. You get me? Watch how you approach it now. Watch this now. Now, if A, B, and C are angles in a triangle, right? A, B, and C are angles in a triangle, and it is pi radian. Let me see. Given that the sum of A, B, and C in a triangle is pi radian, but sometimes they still that they're angles in a triangle and they must add up to pi. Because there's 3 angles in a triangle, they must add up to pi. So it means then, just to begin with, A plus B plus C must equal pi. Sometimes you're working with degrees and you have to put 180 degrees. That's to begin with. A plus B plus C is equal to pi to begin with, right? And I don't know A, I don't know B, I don't know C. But them add up to pi. This question must do this. Show that the sine of A is equal to the sine of B plus C. On the sine of A. So see the expression here now. Since I'm on the sine of A, I'm going to take them two here and subtract it over this. So it means that A is going to be equal to pi minus B plus C. Now what am I going to do now? If A equal pi minus B plus C, then I can take the sine of this side and take the sine of that side. Let's make it a little smaller. Looking kind of large on the screen. Right? Let's make it a little smaller. Bring this over a bit. Right? So what I'm going to do, I'm going to take the sine of both sides because I'm trying to get sine A now. So it means then I'm going to take the sine of the left side, sine of the A, must equal the sine of the right side. All right, that's what I'm going to do. So let me just shift this over some more so I can demonstrate a little bit better what I'm doing. All right, so I'm going to take the sine of both sides. So if the angle here equal an angle here, then the sine of this angle must equal the sine of this whole angle. But then you must know, even from your quadrant diagram, that sine is the same value here and here, right? That sine in this quadrant, because sine is positive in both of them, right? If this was, for example, sine of alpha, then this would be the sine of pi minus alpha. It's the same value you're gonna get. You understand? So the sine of pi minus alpha is equal to sine of alpha. So you have to know that the sine of pi minus this is equal to see the sine of that. Look at what I'm saying now. If the alpha is the B plus A, then this alpha is the same B plus A. We know that this is true that I've drawn there. But the sine of an angle in the first quadrant is the sine of pi minus the same angle in the second quadrant, because sine is positive in those two quadrants. You know that for a fact. So if the alpha is B plus C, then I can replace, then it means that this expression is the same as that. So then it means then that this expression really is like I have that. And so it is equal. And so this expression over here is equal back to that. Right? So I can conclude from all of this that this side, which is sine of alpha, sine of A, sorry, must be equal to the sine of B plus C. You understand that? Understand that?
So say that again.
So I can understand it. You have to know that sine of pi minus an angle equal to sine of the angle. You can see it, remember in these two quadrants, sine is the same value. Sine of an angle alpha, the first quadrant, equals sine of pi minus alpha. But sine is positive in the first and the second quadrant. You have to know this. Sine of pi minus alpha equals sine alpha, get the same value. Example. Sine of 30 degrees is the same as sine of 180 degrees minus 30 degrees in the second quadrant. This is in the first quadrant. This is the equivalent angle in the second quadrant. So it means the sine of 180 minus 30 is equal to the sine of 30. So if I change that 30 here, let me put pi there. Let me put pi. Just that I don't want pi. Let me put pi by 6. Sine of pi by 6. That's in the first quadrant. It's going to be the sine of pi minus pi by 6 in the second quadrant. Because remember, in your quadrant diagram, sine is positive here and here. And this quadrant is alpha. And this quadrant is pi minus alpha. And sine given the same value for sine. It's the same value. So the sine of alpha is the same as sine of pi minus alpha. So if we have sine of pi minus a, b plus c, then it's equal to the sine of b plus c. Because this expression now, right here, is like my alpha. So this is my alpha. So I'm working on this side. But if you want to do a lot of work, they can expand this out using a compound angle, but you don't need to expand it out because you should be armed with this knowledge that an angle alpha in the first quadrant is equivalent to pi minus alpha in the second quadrant. And in the first and the second quadrant, the sine of the angles is the same. That is why if you're trying to solve for an angle, sine of an angle, right, that is equal to a value. So K. You take them first two quadrants then because sine of the angle is the same value in those two quadrants. But where in the first quadrant an angle is alpha, the equivalent angle to alpha in the second quadrant is pi minus alpha. In the second quadrant, it is pi minus alpha. So it's the same. So so therefore, because sine is the same value in those two quadrants, then the sine of this is equal to the sine of this. So that's what I have applied here in this up here now. That's what I've applied right here. I have the sine of pi minus b plus c. This sine of pi minus b plus c must be equal to the sine of b plus c. Because b plus c is like my alpha. My alpha. Understand that? You can understand it?
Yes, sir. Yes, sir.
Right? Now another way we could do it, is waste time and actually expand this out of the compound angle, but that's a waste of time. You know to just know that this relates to the sine of an angle in the second quadrant because it's pi minus the angle. And sine of an angle in the second quadrant, if it is pi minus the angle, is the same as sine of the angle. Because the equivalent angle in the second quadrant is pi minus. So the sine of this is equal to the sine of that. That's what we basically say. All right? So that's how this came about. So from here, I could draw this conclusion that I have on the screen. I'm going to show this as my result, my reason for doing this. So maybe what you can do, is put the alpha right here equal b plus c. So I'm going to take the alpha and put as b plus c here. Then this alpha is also b plus c. Shift this over. This alpha is also b plus c. So sine of pi minus b plus c is equal to b plus c, not alpha. Change this again. Is equal to the sine of b plus c. That's why I've gotten to this line, which is shown. Shown. That's what they said to show. So far, so good?
Yes, sir.
All right, so watch this now. So we have to be mindful of now. We have to be mindful of, and this might be applicable in another question. We have to be mindful of is that you don't know which angle is A, which angle is B, and which angle is C. So those three angles can be interchanged in any order, because it could have been that instead of moving the B and the C, it could have been that I moved the A and the C and left the B, or it could have been that I moved the A and the B and left the C. So it means therefore, can mute the mic, please, mute the mic. It means therefore from this, it can be deduced. It can be deduced and it becomes applicable in other questions. It can be deduced that the sine of the B is equal to the sine of the A plus C. And the sine of the C is equal to the sine of the A plus B. All I know most of the three letters. A, B plus C. B, A plus C. C, A plus B. You get me? So from this, these are also true. Those are also true. Do you understand that?
Yes, sir.
Good. And that's what we're applying in the second question here, which is a very simple and easy application. Because once I have this now, and I'm going to show this now, see? So I'm going to show you. Show so the sine of A plus the sine of B plus the sine of C is now equal to these things. Easy. But this one is really the sine of C. This one is really the sine of A. And this one is really the sine of B. So true. Or you can come back to these three equations now. Come back to these three equations. So if I'm in the exam room, right? I'm going to prove this. For these two, I'm going to say also, because both your answers. I'm prove this in the first part. You know. Then to prove the second part, I'm going to say also. And I'm going to write this, I'm going to write that. Then now I have to do now to prove this equation now. You just add up everything, add them. Adding, so I'm going to call this equation 1, call this equation 2, call this equation 3, and add them, just add up everything on the side here, and add up everything on the side here. So I'm going to add 1, 2, and 3. So I'm going to say something like adding 1, 2, and 3. So I'm going to add up everything on the left side. Sine of A plus B plus C. See here, the sine of A plus the sine of B plus the sine of C. That's everything on the right side must be equal to the sum of what is on the left side. So they're equal to this one. But they have the other way around. So you can put them in any order. You can do this plus that. I just need to add up the three of them on the right side now. So I'm going to write the sine of A plus B, that is this one, plus the sine of B plus C, which is this one, plus the last one, the sine of A plus C. Shown, it's another shown that this equals the sum of these. Shown. So it's a very easy question, really. Shown. Very, very easy question. But I want to find one of these R sin R cos for you. So which part of this question you were really, really interested in? Which part of it? Up here, sir? Or down here, sir? Which part of it you were really, really interested in? Because sometimes I ask for the question.
So I
All of
didn't
it?
So I didn't understand the B part. I didn't understand what to do. For the B,
Say that again.
So
Yes,
that
sir?
was the maximum value.
This one?
Of, yeah,
Or
that
this?
one. I didn't understand.
This one, this. You understand
No,
it
the
now,
other
though?
one. Yes.
This one? You understand what to do now, though? Yeah, man. Just plug the extreme value. See, the extreme value of this is that the R is that the function. Remember, I said this equal a function, you know. And because the cos part of it, the cos part of this function right now, the cos part of the function right here, can only go from -1 to 1. And when you multiply by the R, it means that the overall thing is going from -R to R. That's the extreme of the whole function. So the function has a minimum of -R and a maximum of R, and it passes through 0. So if you want to record the maximum minimum of that, just put the extreme values and the 0 in this and see what each of them give you, and give them the highest one or the lowest one, depending on what they ask. That's a safe way to do it. You have a reason, no, just do that. Okay? Any other question you want me to do? There are some recent paper with similar question. Let me see if I can find a recent one. Just to try to emphasize this thing where they give you this with the other way around. So you're basically saying you are okay with writing these as that, right? You're okay with those.
Yes, sir.
What method do you use? Do you use the expansive method where you square and add and all of that?
No, sir. That's usually.
Huh?
That's usually also the A and the B.
You use the R equals square root of A squared plus B squared, and that.
Yeah.
So good. So you know you have to do the right setup, right?
You
have to set up the right way. And you know that if they give you and they're trying to force it, they'll give it the wrong format, you have to switch it around. You see those questions before, right?
Yes, sir.
All right, beautiful. All right, which other question you want me to do? Your time, your time. Which other question you want me to do?
Integration.
Which one?
Also, the
Specify.
functions one first. The function one. So go up, up, up.
On the same paper?
Yeah.
All right. This one right here, sir?
So you see the B? That one I don't want to go in there.
Where's the B? Where's the B? Right, sir?
No, not the whole thing. I said the second B.
This one? That's a composite function.
Oh, no, sir. Sorry, sir. The one under that. That one I don't understand.
Which one? This?
Yes, sir.
That?
So I don't know what's going on. Yes, sir.
That is something from C-Sec you're supposed to know, I'm telling you. That's what we call the inverse of a composite function. And so you must show it. So you basically have to prove that the left side of that expression equals the right side, but it's something that is true. No, with all them fancy O and them stiff they're putting in there. All of that is necessary. You see this is written simply, and all the of x that they have here, you don't need to put that. Simply put, you see this whole thing can be written as this. Watch this now. F of g r to the minus 1. I don't need to put the of x or the O in between there. I don't know where CXC committed all these things. I don't know who's setting these questions, right? We don't need to do all of that. Just complicating it. To the minus 1 is equal to g to the minus 1. You see if you have our g in here, the inverse come out here first. Of f to the minus 1. It's the same thing that you know. This and this are the same exact thing. This expression I'm telling you to prove is just this without the fandangles. I don't need to put on them of x business here because I only work in functions of x. And I don't need to put this O business that I have in between there. Those two things, this that I've written is the same as that. Do you understand that first? So this is what I'm really proving. You get me?
Yes, sir.
Good. So to prove this, to prove that this equals this, I have to work out an expression for this and work out an expression for this, and they're supposed to be the same. That's what it is. All right, so let's do it. Let's do it. So the f function is 3x plus 2. I don't need to put on the of x on it. We're working in functions of x. I can just call it f. And the g function is e to the 2x. And the question I cannot unreasonable because to get the inverse, you have to go into log ln. Yeah, but log upon your syllabus, so it's okay. Log to base is on the syllabus code. So first thing I want to prove the left side. So I'm trying to prove this first, the left side. So let's say I'm trying to prove the left side first, which is fg r to the minus 1. I'm trying to find what this is. Not prove. I'm trying to find what this expression is first. First, I need a composite of these two functions. How do I do a composite of f to g? I put the whole of the g into the f right there. That's how I do the fg. So I'm going to calculate the fg first. I'm trying to prove this. So the fg right now, I don't need to put the of x on it, guys, and complicate. Just put fg. Is obtained by putting the f into the g. How do I put the f into the g? I put the entire f function into the g where x is. So it's going to become equal to 3 times e to the 2x plus 2. This right now is my fg. After I found my fg, now some teachers call it y and all them things that you don't need to. To get this inverse now, I'm going to inverse this function. Watch this now. I'm going to inverse this function without all the flaps. This is the range of my composite function. It's going to become domain. So this becomes x. Some teachers will call it y and then change it to x same way. It don't matter, same thing. Equals. You see that x right here, so? It becomes the inverse of this. This x up here becomes the range in inverse function, which is the inverse of that. So I'm going to write the 3e to the 2. The x here becomes the inverse of this. If it was a y, you'd have put, I think let me interchange it. No, if it was a y first, you'd have put y right there, right? But now I use x and y. I'm just going to put fg all to the minus 1 and put out this plus 2. If you want to put y right here, so no problem. No problem if you want to do that. Then what I need to do with this now is make this thing up here so the subject. That's what I'm tasked with doing now. Make this thing up here the subject. So first thing, I'm going to transpose this 2 and divide under the 3. That's the first thing. I'm transposing everything away from this thing right here because I want to make it the subject. So I'm going to get x minus 2 over 3 equals e to the 2 fg all to the minus 1. Then now, to get rid of this e, I have to take logs of both sides, log to base e. So I have to ln both sides. I have to take the ln of both sides. So I'm going to shift this over a little bit so I can show the ln. I have to take the ln of both sides now. Because I want to get rid of this. You want to get this from out of the power. When something into the power, you want to get it out to take ln of both sides. So I'm going to ln this side and ln this side as well. So I'm taking the ln of everything there and ln everything there. Then the law says that this whole thing comes to the front. And then the ln e is 1. So really and truly, this side becomes equal to just this. So I could have gone the other way still, you know, and I just wrote that. Right? So in any case, I get ln x minus 2 over 3 equal to 2fg all to the minus 1. And then to leave this as a subject now, because we got times ln e now, times ln e. Times ln e. But the ln e is just equal to 1, right? The ln e right here is just equal to 1. That ln e right there is just equal to 1. So I don't even have to show it. So I'm left with this right now, because this is 1. Now take that 2 here now and divide it over here. The entire side I divide it. I'm multiplying both sides by 2. So I'm half here, so and half here, so to cancel this. So you can't bring it under here, so now. That's a big mistake, right? So I'm going to take half of both sides. So when I do that, I'm going to get fg all to the minus 1 equals half ln x minus 2 over 3. Now this half, remember, I can come up here as a power. So we can go further and say fg all to the minus 1 equals ln x minus 2 over 3 to the half. And a half power, you know, really just means square root. So we can actually just write it as a square root. So let's just write that as a square root. Square root of that, ln of the square root of that. So my fg to the minus 1 is equal to this. So I have the first part done. So fg to the minus 1 is equal to this. So we calculate a side here now. I'm looking for this expression. All right. Let's go back now. So what will that mean this question? You would have had these already from this line. So this would have been easier, but I'm going to work them out from scratch. All right. Let's go back to the same 2 function up here. The f and the g. I'm going to copy down now for the next part. Copy these down for the next part. I'm going to do it here now. So now how about the same 2 functions? And now I'm trying to show g to the minus 1 of f to the minus 1. I'm trying to find that now. So to find that, I'm going to inverse them 2 functions here first. Inverse the 2 of them. All right, put this smaller. Put that smaller I want. All right, and shift this over a little bit. All right, so ready now. I'm going to inverse this first. All right. So when I inverse this, This f becomes x equals 3 times this x becomes f to the minus 1, the inverse of f, plus 2. So to make this the subject now, we'll transpose the 2 and then divide under the 3. So I'm going to get x minus 2 over 3 equals f to the minus 1. That's the first thing. Then now, I forgot now I inverse the g right here. Inverse the g now. Because in order to do this, I need a 2 inverse and then I'm going to put the f to the minus 1 into the g to the minus 1. That's how this composite is set up. So I need the f to the minus 1 and the g to the minus 1. But the f to the minus 1 here already. Now I need the g to the minus 1 for me. Watch this now. So I'm going to inverse this now, the g. This g is range, becomes domain, which is x equals. This x is domain, becomes range. I get e to the 2, and the x becomes g to the minus 1. Now I need to make this g to the minus 1 the subject. What do I do? I'm going to take ln of both sides. I'm going to do ln x equals ln e times e to the ln e to the 2g to the minus 1. Then this power comes to the front. So we have now that ln x is equal to 2g to the minus 1. Because remember, you're getting ln e again. Shift this over a little bit. Shift this over a little bit. Everything can shift over a little bit. So right here, I'm getting ln e again, you know. ln e. I'll move this power to the front. I'm left with this ln e. But ln e is equal to 1. So this ln e right now again is equal to 1. So I'm really left with this. What can I do? I can divide by the 2 again. I get a half. Watch it now. So I'm going to go now and get a half ln x equals g to the minus 1. Then a half come up here, so I'm going to come 4 to the half, right? Which is a square root. So I'm going to get that the g to the minus 1 is actually equal to ln the square root of x. That is g to the minus 1. So now these two now to composite. Now this f to the minus 1 and this g to the minus 1. I'm using those now to form this thing that I want. Let's go back for the blue now. So this thing that I want, which is g to the minus 1 of f to the minus 1, is formed by putting the f to the minus 1 into the g to the minus 1. So it means that I'm taking this f to the minus 1 here, with a different color to show it. I'm taking all of this f to the minus 1 here. I'm bringing it and put it into the g to the minus 1 where the x is right there. That's what I'm going to do to form this composite function. When I do that, I'm going to get this ln, the square root, and where the x is, I'm putting all of x minus 2 over 3. And if you look at it now, I have gotten the second thing. Because if you notice now, see this expression right here? ln x minus 2 over 3 is the same expression I got up here. ln square root of x minus 2 over 3, same thing. X minus 2 over 3. Bang! Just need to put a bracket on it, look exactly alike. Like that. Therefore shown that fg r to the minus 1 is the same as g to the minus 1 of f to the minus 1. That's it. All right, Mom?
Yes, sir. I got the wrong inverse for G, that's why.
You got the
I
wrong
got the
what?
wrong inverse for G, that's why I didn't get it.
Same. Oh, you had the right process, but you did the wrong thing.
Yeah.
All right, good. All right, that's
So,
good.
so I have one more, right? But before we do that,
Yes.
What's the
Uh-huh.
formula for the modulus, like the B modulus, the minus B?
The
The
what? The
formula
modulus
you
of
guys
what?
do, the formula function of the modulus formula.
Modulus
The
of what?
the formula for the modulus. You know, like the minus B is equal to B.
I don't know what you're talking.
So let's
Modulus
use
of
this
what? For
formula to
vector?
find the modulus. No, for modulus, the one just below it.
The one at what?
The one for modulus.
The modulus function?
Yes, sir.
You don't need no formula. Well, like the modulus of x, where it equal to? So you mean?
No, sir.
No, man, you have to tell me exactly what you're talking. I just don't
No,
know what
sir.
you're referring to.
Every time we just do a modulus question, you say you just
Oh,
put this one formula.
the modulus
Yes.
function.
Yes,
Oh, the
sir.
identity. Oh,
Yes,
the
sir.
identities. All right, the identities that you must know. Okay, it's on the must know sheet, you know. But all right, I'll tell you. It's on the must know sheet that I gave you. It's the modulus identities. Okay, the modulus function. All right. So, for example, if you're solving an equation, the modulus of A, I'll give you that, right? The modulus of A equals B, then the A equals plus or minus B. That's your solution. So if you get this, solve this. This means this. If you have the modulus of A equals the modulus of B, they're the same thing. This equals this. Oh, same thing. This equals plus or minus again. Means that A equals still plus or minus B. It's still equal this. Now, what are you going to make the distinction between this result and this result? What do you think you're going to do? It look like the same thing, don't? What are you going to make the distinction? What do you think the distinction will come about? Because this is the modulus of A equals B, and this is the modulus of A equals modulus of B. But I'm saying that you solve this and you solve this to solve. So I'm saying solve this. So I'm basically saying to get your answer, to solve this. So here I'm saying solve this. Solve this. And here I'm saying solve the same thing. Solve this. But these two things are the same, but these two things are not the same. What do you do to make the distinction? Because this one give the same result as this, you know, but they are not coming from the same modulus equation. What are you going to do to make the distinction? What are you going to do? I'll tell you what you're going to do. You have to test your answers in this. Answer that I get, you have to test them back in this original thing. See? Test your answers in this, the original equation. You get me? So instead of one, for example, suppose when you get your answers, right? It is causing you to get something like the B come out negative, like the B come out to a -4, for example. You cannot accept when you test the value. Why? Because you know that the modulus of a value cannot be negative. The B has to be a positive value when you're done. So you test your answers to see if it makes sense, if the answers where you get will work in the original equation that you're solving, if the answers will work in the original equation that you're solving. Generally speaking, when you're solving modulus functions, you test your answers because the modulus function is a peculiar kind of function. The mathematics process that you use to solve modulus function don't know that you're solving a modulus function. You know? You don't know that you're solving a modulus function. Because a modulus function, for example, is one where, for example, you have a line that will normally go like this. And this line is, for example, say this line is So this line is y equals 2x minus 3. But you modulus this, you know. The part of gone so now, you know. The part of gone so, you know. Right? So it changed from this whole line come down here, so. And it is now just that. So instead of intersecting the y-axis, for example, on at -3, it is now intersecting at 3. The mathematics that you're doing with this, don't know, especially if you go square it. Because the modulus square and the regular function y equals 2x minus 3 square is giving you the same thing. This and this is the same thing. So if you have the original function, right, y equals 2x minus 3, we cut the y-axis down as so. I have this function, we cut the y-axis up here so. And you square that one here and you square that one here. You're getting the same result. And that is why you have to test the results that you get. Because the modulus function is a peculiar kind of function. Very peculiar. Right? Some of the values that you get are inconsistent with the process that you use to get there. So that's why when you get the answers, you have to test. Because the process that we use to get answers is the same process that we would do with our normal function. But the modulus function is a function we just add on them two things upon it. And we just throw away the negatives off of the value. We just throw away the negative off of the value and we just drop them off. So when we calculate a value and the value for y come out to be -3, we just drop out the negative off of it. The mathematics don't know, so you drop out the 3. So the mathematics is still calculating as if the -3, as if the negative was still on it. But you have dropped it off. You just drop it off. That's what the model is doing now. You just take a negative value and turn it positive. That's what the model is doing now. The mathematics in a lot of the cases don't know that that has happened. The mathematics is still calculating as if it is still a -3. But we have changed it to a +3. So therefore, when you solve a modulus function question, you have to test your answers. So let me get back to what I was doing now. So the key to make the distinction with these things is to test your answers in the original to see which one of them still satisfy the original. All right, the original. Remember, the original thing is that a modulus expression cannot be negative, cannot be 0 or more. So any value that will cause the modulus to be given a negative value is unacceptable, is inadmissible. And that's how you'll make the distinction. So the answers that they get from this, the answers that they get from solving this is the same answers they get from solving that. But some of the values for this maybe can't work, while some of the values, maybe some of the values for this one can't work, but all the values can work for this one. Maybe that's what it is. So you have to test the values to see which ones you eliminate. And that's why you make the distinction. But let's look at the other things. So those are equations. Those are equations. Remember these things I'm going to mark down now. Equations. So I'm going to give you the form result for the modulus again. Now, if I'm solving an inequality with a less than, like for example, the modulus of A is less than B. Just remember this now. The less than means that you are between the A, the positive and the negative of B. The A is between the positive and the negative of B. So the result for this one is that the A is between the positive and the negative of B. So notice, you know, up here we are equal to the A and the B, equal to the positive A and B. Down here now, when it's a less than, we are between them. We're not equal to them anymore. We are now between them, the negative and the positive of B. So this is your form result. What you do? Solve this. So if you're given this, what you do, this implies this. Solve this. Solve this. If this have an equal on it, you put an equal upon them too. That's all. But me leave the rest. That's the form result. And again, when you get your answers, you get your answers for these, test your answers. in this, in the original thing that you're solving. See if them work. See if the answers will get work in the original thing. Don't just accept them and go about the business. Then the other one is if you have a greater than, right? Look carefully in if you have a greater than. So if you have the modulus of B, modulus of A, greater than B. So you know this one, the A is between them. There's a less than, it means between. You can remember that, you know. The less than means between. When there's a less than, you're going between. You're going between the minus and the positive B. The A is between the minus and the positive. Between. So here is between. There's a different color for this. The less than means between. The less than sign means that you are between. Between. You can write it out. Right off here. A is between the negative and the positive. A between. Less than means between. Negative B and positive B. That's what the less than indicate. The A in the modulus here is between. When it's equal to the positive and the negative. Up here as well. Equal to the positive and the negative. Those both cases. And you test your answers to switch and eliminate. When it's a less than you have, then the A inside here now equal again. It goes now between them. So it is greater than the smaller value, but less than the larger value. And you solve this, it becomes the inequality. When it's greater than now, so greater than now, right? So it means now that the A is outside of them, you're not between them anymore. The A now is outside. It's on either side of them. It is, I use the word outside. The A now goes outside. It goes outside. The minus B and the B. What that mean? What that mean? It means that you're not between them anymore. It means that your A is less than the smaller value. The A becomes less than the negative B, or the A becomes greater than the positive B. If I draw inequality to represent it, let me just put a little inequality to represent it for you, so you can visualize what I'm saying. Visualize it for you, make you see it. All right, let me shift all of this down first. Let me shift all of this down first. Shift this down. All right, shift this down. I'm giving you a visual of what this means. So what is going to happen is that, like you have a number line, you have negative B right also, you have positive B right also. I'll put them closer. I'm going to copy the same diagram down. So like you have a number line, you have negative B, you have negative B, and you have positive B, right? And your A is between here. That's what is happening with that one. Your A is between those two values. It is a less than. Form results. You don't have to go the long process. Some teachers say you square both sides and solve and all of that. You don't have to do it to them form results here. Believe me. These are standard form results. When you square both sides and expand, you're going to get a quadratic that produces this situation. Guaranteed. Guaranteed. The solving function that you end up getting to work out itself like a charm. That's what happens up there. So you solve that. Down here now, the A goes outside of the A and the B now. So if I draw about this number line now, just to give a visual of it. I'm going to draw about the number line now like this. Bam. I'm going to put the minus B here. Minus B and the B. You can see the screen. Everybody can see it, right? I know I'm writing a little bit small. Can you see it?
Yes, sir.
And put my values on here now. Those are my values. What happened now is the A gone to the side now. And A gone to the side now. Outside those two ranges, those two values. So the A becomes greater than this upper value, or the A is less than this smaller value. That is what happens when you have a greater than. The A goes outside. What you do? You solve this. You're solving this. Right? So you solve this. So you solve this. Come here, Mr. Shaw. Solve this. You're solving this inequality right here. That's what I mean by solve. But I'm just giving you a visual of what happens when you have this. This is the result. And this result is expressed. The function in here becomes less than the negative of that. See? And the function in here, whatever is in there, becomes greater than the positive of this. And that's what it is. That's what it would appear on our number line we're talking about. What do we do? What do we do? We get our results. You work and you get your results from solving down here. So you test your answers in the original thing. In this. All right. Now watch it now. See it here now. So I give you 4 conditions, 4 things. 1, 2, 3, 4. Those are form results. You know what are the form result? When you have modulus on both sides of an inequality, there's no shortcut. You have to square both sides, expand, and solve. So when I have, like for example, modulus on both sides of an inequality, I have the modulus of A. If we have this now, put it in blue. We have the modulus of A less than the modulus of some other function B, or the modulus of A greater than the modulus of some other function B. There is no form result for these. For these, there's no form result for these. You have to square both sides, expand, and solve. Here, write out for you. Square both sides, expand, and solve. Square, these are the only one you really need to square both sides. You have some other ones up here, you know. It might be convenient to square both sides, you know. Up here, you know, sometimes, you know. We don't have to. Up here. These are form results that can be used. Don't you so? Now, a form result, when you have modulus on both sides of an inequality. Note, when you have modulus on both sides of an equation, no, not that one, here, of an equation, no problem. I still can have a form result. When I have modulus on both sides of an equation, you can have a form result. But modulus on both sides of an inequality, dog, me have a super problem that. No shortcut. Square both sides. Square both sides. Expand and solve. But still, when you're done, you test your answers still. Still test the answers. So when I say square both sides, expand and solve, I'm write them out for you. So I'm write them out for you. So write them out for you. So this one would come to a squared less than b squared. Solve this. And this one will become a squared greater than b squared. So you don't trouble the sign, you know. You square both sides. You don't trouble the inequality sign. Just square the two sides. Right? Simple, you know. With a side there, less than a side there. Then we square the two sides. Stays as it is, right? So you square both sides, expand, and solve. Right? And then you solve this. Solve this. and then you test your answers. So you have modulus on both sides of inequality. That's the one that you really have to expand both sides. But some teachers teach it that you square both sides, even that one there, that one there. Even this one up here, they're telling people to square both sides, and this one. You don't need to. Form results. Those. Form results. Those are form results. All of those. This is the one that you have to square both sides. Expand and solve. Okay, mom? That's what you wanted, right?
Yes, sir.
Alrighty. Righty. What else? You're ready today now, okay, going on. What else you want me to do? You calling a question.
So
now.
one more, the differentiation one.
Where?
So on
This
this
same
one.
paper?
Yes, sir.
Alright.
So I think it's 5B.
Yeah, 5B.
5B. Oh,
Yes,
so
sir.
like you wanted to.
Yeah.
This guy right here, sir. That I beat you, you know.
So scroll.
I'm gonna beat the two of you.
Sir, I know to do this one.
So not that
That's
one.
quotient
It's the
rule.
next
Eh?
one. So not that one.
Not this.
No, so
Oh.
scroll
That's
down a
quotient
bit.
rule. Quotient rule that. Go further. But this one,
No.
yeah, not either. Oh. I want to have another differentiation on this. What are this is now? It's a foolishness now. Anything else on this? Other different. This one done, sir? Other
No,
different
sir.
paper. Other different paper. The different paper you're talking about.
So scroll up.
Up. Oh, you wanted this parametric one? Well, that's not that was just a substitute. I told you. So, right? So this one just make T the subject, and then substitute we get in this one, and you end up get this equation right here, right? So that's free marks question. Now another differentiation on this. That's it for differentiation on this paper. So you come on. Let's. What else you want to do? Talk fast. Can't have differentiation here for sure, but this is a quotient rule, right? This is a quotient rule. Is not this right? You know how to do this?
No, sir.
Come back to
Yes,
that.
sir.
Huh? All right.
Yes, sir. Not to do.
And is not this one?
Oh, it was 2014. Sir.
Huh?
2014.
2014. All right then.
Yeah. 5B.
All right, 2014. 5. Where are you? Grammars 2014. Where are you? Show yourself. There you go. On yourself. 5B. This guy right here, sir. This one?
Yes, sir.
All right. Okay. All right. Oh, first principle differentiation. Remember we had a class? We differentiate from first principle. Right? So, yeah, you remember that
So
video
I started
exists?
it, but I kept getting stuck.
All right, we could go and see what happens. Let me tell you about differentiating from first principles, these expressions. You have to go through a process where you rationalize a surd wherever it exists. When you get those to do. You have to rationalize a surd wherever it exists. Right? And see, even if they give you with x to the power half to do, work with the square root. Work with the square root. Right? And set up the difference of two squares and so on. Right? Rationalize. All right, we can look at it. Now, the first thing, the function is y equals 1 over the square root of x, right? That is a function, right? We can call it f of x, so we can reference it. For example, f of x, all right? Call it f of x. Now, f prime of x, which is first derivative of you have to write that down, you know, is equal to the limit as h tends to 0, see here now, of 1 over h. You're trying to get rid of that h. Remember, your whole process is to get rid of this h. Of f of x plus h minus f of x. Some teachers put the h under here, so. But I like to keep it out the way and just put it there, so, right? And keep it out the way. And your whole aim is to get rid of this h by some cancellation a lot of the times. So you're going to work inside this, so you can, for example, cancel the h with this one. When it's a sine one, what happens when you differentiate the sine and the cos, you end up with a situation where you get the sine of something with the h, like 2h over 2h. And then this equal 1. When you take the limit of it, that's where you get rid of this h. So with the sine function ones, you move the h. You get a function like this inside there with the sine and cos ones. Right? There's a class that we did. And so if you have that, you take that h here now and slide it under here. So if it's a 2 you have this, so you multiply by a 2 under here, and 2 back out here, and then this would become equal to 1 when you take the limit. All right, you just have to watch back those videos. But I do it a way where I put my 1 over h. Then now you're setting up these based on this function. All right, so what this now becomes equal to the limit as h tends to 0 of 1 over h into, what is f of x plus h? Means that this x becomes x plus h under there. So it becomes 1 over the square root of x plus h minus f of x, which is just that, which is 1 over the square root of x. That's how you start. They want to make this into one fraction now. That's the next step. Make that into one fraction. Remember, you know, so the h is under here. You're trying to get it from under there. To cancel it with that. Right? But you want this to become one fraction first. So you put it as one fraction first. All right? So you're going to get equal to the limit as h tends to 0. I left out the 0 here. Of 1 over h. And we are juggling now. And to get h from under here, you're going to have to rationalize it. And remember, we're going to put this as one fraction first. So to put this as one fraction, remember now what you're going to do? You're going to multiply this fraction by root x over root x. And multiply this fraction by this denominator, which is root x plus h over root x plus h. Can imagine that, right? That's my next step. Multiply this one, numerator and denominator with root x, because I want the two denominators to become the same. I multiply this fraction by root x plus h over root x plus h. Hope you can all see that. Leave it in red. Leave it in red there.
Yes, sir.
Leave it in red. So I'm gonna move this bracket and put it. All right, I'm gonna put it. I'm gonna move this bracket and put it. So I'm gonna multiply up here by root x plus h over root x plus h. All right, that's what I'm doing. So, because I want two fractions of the same denominator. What do I end up getting? I end up getting root x minus root x plus h over a common denominator of root x times root x plus h. So far, so good? I'm not put a bracket there yet, because I'm going to make an adjustment now. You see the h that is under here? I need to get it from under the squared sign. Cancel with the one out here. All right, let me write this better. Root x plus h. Right? The h that is under here, I need to get it from under the square root sign so that I can cancel it with this one. The whole process of differentiating from first principles is get to a stage where you're able to get rid of this. Once this is gone, then I can apply h equals 0 everywhere there's a h, and to work out itself. So I need to rationalize this to get the h from under the square root sign. That's what it is. I have to rationalize it to get the h from under the square root sign. So, and I want the h to be up here on the numerator to cancel with this down here. So I have to get this h from under the square root sign, I have to rationalize this. How do I rationalize this? Multiply by its conjugate. Multiply it by its conjugate. Let me shift this over a little bit. So I'm going to now multiply the numerator by the conjugate of this to set up the difference of two squares. So I'm putting by the same expression but with a plus. The conjugate is when you put this, change the sign between two values. So I get the square root of x plus the square root of x plus h. But I'm divided by the same thing, square root of x plus square root of x plus h. So I'm now going to put back my closing bracket here. So remember now, this denominator is not multiplying by that. But I'm not going to change the values and try to expand it out. And then this times this now is the difference of two squares on the numerator. So this then becomes the limit as h tends to 0 of 1 over h into 1 over h into the difference of two squares now. So this times this up here really becomes this term squared, which is x, minus this term squared, which is x plus h. That's what the numerator becomes now, the difference of two squares. It becomes this term squared, which is x, minus this term squared, which is that, x plus h. And I'm putting all of that over the product of these two things. So I'm going to put the square root of x times the square root of x plus h times, I'll put all this in a bracket now, square root of x plus square root of x plus h. Like that. But good with that? But okay with that? We'll move on.
Yes, sir. Yes, sir.
Now watch this now. It's the whole numerator here, so that I have. It really then just works out to be negative h. Can you all see that? Can you see that become negative h? Because if I expand this, right, if I expand this bracket, I'm going to get x minus x, so the x gone, minus h. So this whole thing reduces to negative h. So I'm good to go now. I have reached a stage where I can now cancel. So this h cancels with this h, but I now have a negative 1, see? Negative 1 on the numerator. So now I can do everything in this line now. You see, because this h gone now, I can now apply h equals 0 everywhere there's a h. Because this h is what was giving me the problem. I've gotten rid of it. I know about negative 1 up here. I can apply h equals 0 here and there where I have h's. So watch this now. So I end up getting this being equal to, and when I'm going to apply the h equals 0, I don't write back the limit. Just put the values. So numerator is a negative 1. See there, negative 1 over. When this becomes a 0, I end up getting root x times root x. Root x times root x is just x. X. Bracket. This stays a root x. Root x. Plus, this becomes a root x because when this h becomes 0, this whole expression becomes a root x. Root x plus root x. Bam. That's what I end up getting. Now, what is this finally equal to now? This is now finally equal to 1 over, this is 2 root x. So it's x times 2 root x, which is 1 or the minus,
So
I forgot the
negative
minus,
one.
minus.
Yeah.
Yes, thanks. Minus 1 over 2 times. Now this is x to the 1, right? And this is x to the half. So it's x to the 1.5, that's enough. X to the 1.5, which is 3 over 2. If you want to write it as power, it becomes minus 1 over this 2 times the square root of x cubed. Let's test if that is correct. That's what we have to do next. By differentiating this expression over here the normal way. And see if we get that. If we get this, differentiating it the normal way, then we'll go. So can we believe this, you know? Minus 1 over 2 x to the 3 over 2. All right, let's see if that's what we get. Let's go. So let's leave that one there as my answer. What did I have a while ago? Not sure it's right. Yeah, the 2 under here so means square root. Square root. And 3 up here means power. All right. So let's differentiate this now the normal way and see. So I'm just running like a test. Test the differentiation. So I'm going to test the differential of y equals 1 over square root of x, which really is y equals x to the minus a half. Agree with that?
Yes, sir.
Agreed? Good. I'm going to differentiate this now. dy by dx equals minus half multiplied by the power. Huh?
Sir, could you please scroll it back for a second?
Well, I'm not done yet. We're done the question now.
Oh,
I'm
yeah,
testing.
the question? Oh,
I'm
alright.
testing the differentiation.
Alright,
Right,
sir.
so multiply by the power and reduce the power by 1. So I'm going to get x to the minus half minus 1 becomes minus 1.5, which is minus 3 over 2. Minus 3 over 2. So then becomes equal to minus 1 over 2. Now this negative power means I can bring this under here without the negative. So it becomes x to the 3 over 2, which is what we got right here. So we're good to go. See that? That's it. What you want, what you want to see now? This part. Okay, there's
Yes,
a
sir.
class. There's a class out when I differentiated every function that is on the syllabus. You know, what did this topic? You know, I differentiated every function that the syllabus must differentiate from first principles. I had a class where I did that. That video exists. If you want, can maybe try search for it and send it. We're gonna see it. I did differentiate every function from first principles that the syllabus said we had to do. So there's a method for each one. Right? The sine one and the cos one in particular, important. I can ask to differentiate those from first principles too. You know?
Sir, could you like see if you can like, find them and
The one?
send it?
The video or the one or the sine one?
No, the video, sir. See if you can find it
The
and
video?
send it to me.
I'm gonna dig it up. We'll see if we can find
Alright, sir.
it. We'll see if we can find it. We'll find it and upload it. We're gonna watch it because it will be for sale. Remind me to look for it, yeah? Remind me to look for it.
Alright, sir.
I need to start naming my videos now, so I can think. I need to start naming them. And then I don't remember what time of the year I did it. That's the next problem. So I'm gonna look for we got it now. I'm nearly in a haystack now. All right. That is that. Which other question? You want the next part? On the next part. Next part says, see, this is not first principle. I'm just want to differentiate that, right? That's a quotient rule again. Want to do that part though? Want to do this part? Differentiate that from first, not from first principle. Differentiate that. Are you okay with
Yes,
that? That's
sir.
quotient rule.
So I can do
Do it?
Yeah.
Do it? All right. All right,
Yes,
no
sir.
problem. Quotient rule. Quotient rule. Now, when you're differentiating, you don't work with the root. What you differentiate and work with the root is when you differentiate it from first principles. So you can see the difference of 2 squares, right? You can see the difference of 2 squares that we did a while ago. So you see that say multiply this now by root x plus h. So it's a difference of 2 squared. That's the only time you keep the root. If I'm differentiating this, normally I want to see the root as a power. So I'm going to put a half on it. Remember that. Remember that, like Mr. Labrador. All right. Sheriff Labrador says, remember that. All right. So it's y equals x over root 1 plus x. You don't work with roots. When you're differentiating, put the power. You want to see the power that you're multiplying and so on. So this becomes y equals x over 1 plus x to the half. I want to see the power. All right, quotient rule now. Remember, we're differentiating with the quotient rule. We start with the bottom and end with the bottom squared. That's all we have to remember. You write on the bottom first and you differentiate the top. Can't go wrong. We're differentiating a quotient. First thing you write down is the bottom, the denominator. Write it down up here first. So it becomes the bottom, which is 1 plus x to the half times the differential of the top. We differentiate that x there, you get 1. Then minus the top, which is the x. We're going to differentiate this bottom now. So I'm going to put it in a box because they're composite. I want to differentiate it with this way it's smaller. Because I don't want a space. This is smaller right here. And zoom up, right? Good. So I started with the bottom. So the first thing I wrote down was the bottom right here. Then I differentiated the top right here. Then I minus the top. Now switch on the differentiation now, but it's minus the top. Then we're going to differentiate the bottom now. But the bottom is a composite. So it becomes half, because I'm seeing the power, into x plus 1. Reduce this power by 1. Subtract 1 half, and I'll get minus half. Then I have to multiply by the differential of what's in the bracket. I have to show it. The differentiate what's in the bracket, I'll get 1. Put the 1 there. The examiner see it. So that's it. So it's the bottom. No, so it's the bottom first times the differential of the top minus the top times the differential of the bottom. That's the differential of the bottom. All over the bottom squared. So I'm squaring that now, so it becomes 1 plus x because the half. When I square it, it's half power, becomes a power 1. Done. I'm supposed to simplify. That is it in the bottom. So simplify it. Eh? So simplify your answer fully. Simplify your answer fully. All right, let's simplify it fully. Write what this is first. So this becomes equal to 1 plus x to the half. Look at these numbers now. All right, so this is a half times 1 times x. So I'm going to put minus half x for now. Minus half x. I'm going to put this now beside it, which is x plus 1 minus half all over x 1 plus x. What you do now, because them say simplified fully, right? They want to put half power there and thing, all right? So to get rid of this half power there, I'm going to multiply the numerator by what will cancel that, which is the same thing to the power half. X plus 1 to the half. We'll cancel this, right? We multiply the denominator by the same thing. X plus 1 to the half. Right? Because I multiply this times that the power cancel. Because when you add the powers, you're gonna get 0. Anything raised to the power 0 is 1. Right? So that is that. So ready now. So I'm gonna multiply the whole numerator by this. And I multiply this denominator by that. I think I also want to get rid of this 2, you know. So I'm gonna make it be a 2. I put a 2 beside this as well. 2. So I put a 2 here, so 2. I'm gonna multiply by a 2 here, so 2. 2. All right, I'm gonna take out that times here. So shift this over a little bit. And put the 2 right beside here. And I'm times in that, right? That's what we're doing. Because the question says simplify fully. So multiply by the 2 to get rid of the half here. Ah, shucks. To get rid of this half. All right, let's continue. Next line becomes equal to. Watch it now. So first, the 2 times this. Can be a 2, but watch this now. The half, this to the half, times this to the half. I'm going to give me that expression to the 1. So we can drop out the power. I'm going to also multiply by the 2 there. So I'm going to end up getting 2 bracket 1 plus x first. Then now I'm going to multiply this expression with a minus times this. All right, see it now? Firstly, is a minus. That's that minus. The 2 cancel the half there. And this cancel this. All I'm left with is this x. So I'm subtracting x over. Then on the denominator now, I'm going to come now, boom, I multiply this times that. So this 2 is my only multiple. This is numerical 2. Then this times this, I add the power. This is about power 1 upon it now. Add the powers. I get 1.5. So I get that expression 1 plus x to the 3 over 2. That's 1.5 power. 3 over 2. 3 over 2 power. Now what happens up here now? Magically. On the numerator, I get 2 times 1 is 2. Then I get 2 times x is 2x. And 2x minus x give me an x. I get 2 plus x. Over 2 times, this under here means square root. I'm giving them back in the format that they gave me. I'm giving the answer back in the format that they gave me over here with the square root. So I get 2 times, this means square root of this expression cubed. 1 plus x cubed. It's supposed to be an x, right? Not 2 plus x. And that is as simple as we will go. Go to that. And it's simplified fully in a month. So let's go all the way down. Okay with that one?
Yes, sir.
I think you guys, from tomorrow, I want you guys to focus on the more recent exams. You hear me?
Yes, sir.
Focus on the more recent exam because the format of the questions have changed. So you want to be doing 2023, 2022, 2021, 2019. Work it that way there. Make sure you exhaust your understanding of all the questions on more recent papers. 2023, same thing for advanced.
2023, please.
You want to go on 2023?
Yes.
Send it. I sent it yesterday. And I also sent a video.
So you sent them? Okay. Oh, okay.
I sent a video that I did. So the video is on YouTube. I sent the video that I did. You have to be careful because I saw where some other persons having solutions, and some of the solutions, I tell you, they're not right. They're not correct. Some of the solutions not correct. I mean, I see on my video, I make a mistake, and it's obvious a mistake that I make. It's like a numerical. So like one of the questions, I had something equal 19. Something equal 19. And the next line, for some reason, I wrote something equal 18. I don't know why I wrote 18 after 90. But that's just a numerical error, not an error of principle. What I find is that there are persons there solving the paper and making error of principle. Not about like a numerical error, because anybody can make a calculation error. So I was solving that paper one night. In fact, I was sleeping and I got up late in the night and said, I'm going to work out this paper. Because there's a guy in Tobago that I know, a young man that I like a lot, and he asked me to work it out. I'm going to just wake up one night and said, I'm going to work it out for him. And I worked it out and I sent it to him. right? So I work it out the night, but then I say, let me put it on YouTube still, right? Because sometimes these large files difficult to share. So I'm gonna put it on my channel on YouTube, right? And thing. But then that is it. A lot of people working them out and doing them wrong. But that's what it is. That's what it is. We're all not perfect, right? But you know, if you're making a calculation error, that's fine. But what I don't like to see is the error of principle. I mean, I can make error of principles too. Some of them too blatant and glaring. You know, nobody can make a little mistake, leave off a minus sign or, you know, simple thing like that. But I don't like to see errors of principle. Don't like to see it. And if I put up something that have an error of principle on it, I'm gonna take it back down. Nah, leave it if I see the error. I'm not going to take it. I'm not going to leave it. And even some of the videos, when I look, I see persons who identified some of the errors, and they're putting it in the comments and them. And I still have the video up there, and they're getting a lot of views. A lot of people looking at those videos, thousands of people, and they're wrong. You get me? They are incorrect. So you know, you have to be careful, guys. You have to be careful. A lot of good videos out there, you know, believe me, a lot of good ones out there. But you know, you don't want to end up looking at one. You don't want to just be unfortunate to be looking at one that is not good. And the thing about it, we can find a lot of people solving like CSEC questions and these things. You don't find a lot of people solving like pure maths, even AdMath. A lot of people solve AdMath online, but not a lot of people solve pure maths. Few persons solve pure maths, and some of them wrong. Some of them are too right. I'm telling you. So you know, you have to be careful. You know. You have to be careful, guys. All right, which other question I want to do, mom? Today's your day because you're buyer tomorrow. I'm giving you the full shebang because we're gonna do a session tomorrow, you know, and to see man and Antoine and so on. You can ask me anything in the morning while you are doing your exam. Then when you come on back now, you know, you can come with your question. But I'm gonna try and dedicate tomorrow. Start early, maybe 9, 10 o'clock tomorrow. And I'll do some work for about 2 hours, 2.5. Then we'll take a short break and then I start back. I'm giving my date to you all tomorrow and Thursday. I'm telling you from now. I'm giving my days to you tomorrow and Thursday. All right? I'm giving my days to you. So the exam, what time is the exam? What time is the exam on Thursday for pure maths? What time is it?
I believe
In
it's
the morning.
Mm-hmm.
All right. And the same thing for AdMath is in the morning as well. AdMath is in the morning too. Paper 2.
Oh, yes, sir. Yes, sir. 9 o'clock.
Okay, right. So I'm giving my whole day to pure maths tomorrow. AdMaths people can join too, you know, and if we get a little lull and somebody want to throw in a question, if you really feel like you want to answer a question for you tomorrow, you join as well and we could deal with it. All right, but I'm basically hiding away from work for 2 days so that I can answer all the questions that you might have. Which other question you have, Shadi? And you have to go and sleep, and it's now 8:30. You have exam 1 o'clock tomorrow. You might be
So
you have to sleep. Oh, this girl. So you cannot go into an exam room not rested.
So I would
But
chug
you
an energy drink and I would sleep after.
no. If you ever
So
crash in the
I
exam,
don't know
and if
anything.
you crash, yeah, but you're going at the exam and lose the little that you know. No man, you can't do exam not rested. You have to be rested. The big part
So
of
I'll
it.
take a nap on the drive.
No, not good enough. I tell you, I crash in the exam room. So you not plan to sleep at all? No, man, you can't do that to yourself. You talk about personal experience, you know. Cram for exam already, you know, man. I say, all right, I know everything now, you know. And in the exam, nothing coming out because you're tired mentally. When you come out of the exam and see the paper, you couldn't believe it because you were just so tired, you could not think. I'm telling you, you reach a point of negative return when you study too much and you're not rested. But they're going there and what you know can come out on the exam paper, or then go in there and what you know cannot come out because of fatigue. You cannot fatigue yourself. You Can't take that chance. I don't know, I don't know. Some people maybe can do it, but I tell you, I can't afford to be a C. I'm telling you, that happened to me personally. That happened to me already. Cram all night, going to exam, get very little bit of sleep, nerve shot, in the exam room shaking. See a question, know that I'm doing the wrong thing, but can't even think to do the right thing. And after the exam, I see the paper, I say, wow, look what I did to myself. Better me just get some rest and go there with what you know. Because when you're tired, even what you know will not come out. I'm telling you. But be careful with this not sleeping thing. Careful. Understand? That's why I tell people, better you prepare long before exam period start. Because see, after that experience with me, I don't get anything less than 8 hours sleep before exam. And people who do C-step maths with me and add maths with me before, they will tell you that's one of my instructions to them. The night before exam, especially a 9 o'clock exam, no studying at all. Go to your bed and sleep. You must be prepared before that comes. You must be prepared. Let me tell people the same thing that you're gonna do, that you're planning to do tonight for exam tomorrow. That should have been done multiple times before. I tell people, leading up to the exam period, exam will start leading up to when exam starts. Sleep is a concept for me. I'm not sleeping during that time. Sleep is a concept. I only get as much sleep as my body need. I'm not taking any sleep that my body wants. Only what my body needs. Sleep is a concept leading up to that point. I do not sleep. Right? I only get enough sleep. My mattress goes onto the ground and I sleep on the slats of the bed or something. Don't want no comfortable sleep. Leading up to the exam. So once the days, like 2 days before the exam come, I have to get my 8 hours sleep every night. So you put in all that work, the same work that you're gonna put in tonight to try and learn stuff. Should have done that last month, 2 weeks ago, 3 weeks ago. I'm doing that now.
So it's not that simple.
It is simple.
So no,
It is simple.
isn't.
Let me tell you something.
I was still doing SBS. So.
Let me tell you, you know why you know reason. Let me tell you something. You guys, you cannot leave your faith in the hands of teachers and the people who are preparing. You have to take control. You have to take control. When you go to school and I see a teacher that is giving me negative return, I don't even bother waste my time go back to that class. I don't even bother waste time go back to that class because I'm getting negative return. I prefer to go and take the syllabus and take the book and learn what I have to learn on my own rather than waste my time in a class that is giving me negative return. Understand? A lot of us depend too much on other people to get what we need to get. But to get out of that. And you guys, you have so much thing available to you now. You have all these YouTube thing and stuff. For me, I can be all the way in Jamaica and going through something with you. In my days, if the teacher don't physically come, nothing will be taught. Imagine that. You guys, if you want to learn anything, you have 1 million channels, 1 million videos, everybody online showing you how to do this and how to do that. In a chartered resources. In my day, I had to order past papers from England. If I want a past paper, I send to England to get it. Because in my day, we used to do GCE. And when we send to get past papers from England, we wait 2-3 weeks for past papers to come. You guys may go on Google and type in past paper and get every past paper you want, just like that. Getting solutions, everything, anything you want. Come on, man. And you guys still in a situation where the night before exam, I can't sleep. When I was in school with limited resources relative to what you guys have, and more difficult exams, I slept 8 hours before every exam. After I had that first experience. And that first experience that I had, it wasn't because of my doing actually. because of circumstances, I never get to prepare properly the way I wanted to. Understand? So it's not even was because of me and what I did do. But you have to sleep before exam. That's a long and short of it. In high school now, if you have a university, you have to learn exam preparation the right way. Exam preparation is a strategic thing. It's not anything arbitrary and random. It's a strategic thing. Right? You prepare in a way so that when the exam period starts, you don't need to be studying anything during the exam period. Just look up flashcards and you're revising stuff. You're not supposed to be learning anything new. Just revision in that period. You're not supposed to be learning anything new like you have never done it before. And if it's on your syllabus and the teacher not teaching you it, you go and you find it for yourself and learn what you have to learn for yourself, or you find some other source. You don't wait till exam start to be learning stuff. Right? But anyway, it is what it is. But you don't make this happen to you again going forward. No, you. At any level. You don't let this happen to you. When exam period, you're supposed to be sleeping at night. When exam, relax. If you go to exam centers and see people outside the exam door, studying what? Supposed to be studying anything at the exam door. You get up and you go straight in the room when you go to the exam. You're supposed to be studying nothing. I tell my students, the only question you do after the night before the exam are the ones on the exam paper. You go into the exam with a rested brain. Brain get tired as well. Brains, they get tired too. Just like your body, your brain can get tired. So work your brain. It's gonna get tired, it's gonna get mentally fatigued. You get me? So you can't allow yourself to get to the point of negative return. You have to know what that limit is. You have to know where that cutoff point is. Where it's all right, that is it. Whatever comes on the exam. Oftentimes people study this, study that, spend so much hours, cram for this, cram for that. And then go to exam, it never been necessary. I guess maybe sometime if you're lucky, something you study now for exam and stuff might come, yes, but a lot of the time it don't even work out because I don't know what's coming on the exam paper. To me, I think it is much better if you go in the exam room rested with what you know. Right? So you must prepare yourself. You say you don't know nothing the night before exam. Anyway, a lot of people saying the same thing. So it go. Anyway, I've been talking a lot. What question do you want me to do again?
Sir, that's all for me.
Huh?
Sir, that's all.
Vex?
No, sir.
Oh, okay. All right then. Do you think so? You're gone? You're gonna go and do some bio now, right?
Yes, sir.
All right, cool. All right, so tomorrow after the bio exam, the bio is at 1 o'clock. You said so. You will end up coming in the evening because the bio exam finish at about 4 o'clock your time. So you are 1 hour ahead. 4 o'clock your time is 3 o'clock my time. So if you go home same time, you can catch a good bit of what we're doing then. Just make sure try and come with your questions that you want me to go through tomorrow. We can work up to a point. And since I'm encouraging sleep the night before the exam, I'm not gonna go too late, right? I'm not gonna go too late. I'm gonna assume that when I'm done, you're going to your bed to sleep. So I'll work up to the point where you can all go to your bed and sleep. That's the plan for tomorrow. All right, so you can go and stay here with other students and continue doing some work. All right.
Yeah.
Have a good one, Shadi. All right, go on to your bio. All right, Mr. Nathan, whose exam coming first? Who has have questions for me today? I said Corona, I said Giovanni. Giovanni, long time I don't see you. What you have for me? I have to see my Nathan. What you want me to do?
Oh, sir, I'm good enough, sir. I'm good, man.
You go to do the 2023 paper already?
Yes, sir.
All right. I do have the solutions for that one yet. Funny. I was checking to them, I said, right, I never let people here yet. Never work it out yet, you know. I'm going to try and see if I can do it. But there are some solutions online still, but I don't really like to send people the solution, but I have to work them out myself. But there are some solutions online there. I'm gonna try and work it out myself and then see. Share it with you just in case there's anything, you know.
Alright.
So you do the paper already? 2023, you do it?
Yes, sir.
You check the answers, where you check the answers? You check the answers online?
No, sir, no. I never really find it on, I never really do them thing. I'm gonna check for answers online.
Oh, all right, cool. Well, I'm gonna try to work it out. I'm gonna try to work it out. See if we can work it out overnight. See if we can get up in the night and work it out and then we send it and you look at it. So basically all past papers done from 2023 right down to 2012, I think. All past papers. The only thing I really wanted you guys to do before the actual exam was multiple choice, but good to do it, but we were doing some multiple choice before now. So, you know, I like when we exhaust a lot of multiple choice before the paper two, because paper one helps paper two. But at this 9th hour, yeah. But I like, you know, if you're going through all of them and you're comfortable with all the paper tools, then you can maybe jump on a couple of paper ones, you know, and just sharpen up yourself. And that's what paper ones doing. They kind of give you that the edge, sharpen you up a little bit. That's what the paper ones do. So if I were you and I'm good with the paper tools, confident with the paper tools, then I would just jump on a couple of paper ones and just do some questions there. So you can let me know if which ones you have. There are some in the group. You can do some that is in the group. I can look and tell me which ones are not there, see if I can find them and send them, and you can work them out. I think, yeah, you can work them out and see. You have the last year one, but work them out and see if you have the time. So if you're good, that's all right. Who else have anything to do? Just see, man, ask me a couple questions already. Nathan, you have a question?
So can I ask you to do a 2023 question?
2023? You check out the video?
No, I haven't looked at videos.
You have to check the video first. Which question you want me to do? Which one?
Number 5, the limit. 5A.
5A on the 2023 paper inside. That's all. Send the video now, man. I think first thing you do a jump. That's why I'm send the video today now. I'm saying, but wait, we're not doing 2023 yet. I thought the first thing you guys would have done was jump on that thing there, on that video. I really thought that's the first thing you'd have done. Jump on the video. 5A. 2023 5A. These people really have some nice, interesting questions on it. I tell you, boy, I'm telling you. Some interesting questions on these people. Interesting. When I set it like this is here, I'm gonna tell them. This one right here, so. Remember this question equals 0.
Yes.
All right, so when you get a limit like this, right? We have the limit to infinity. The key to doing a limit to infinity like this is to know that 1 over infinity is equal to 0. That is the key. 1 over infinity is equal to 0, because infinity is a very, very large number. That is the point. Right? 1 over infinity, or the pen not getting smaller, is equal to 0. So to create the situation, so what you want therefore, because the limit is infinity, you want all your expressions to be something over x. You don't want to expand numerator, you want all the x to be in the denominator for all the values in your expression. So what you do, you look for all the expressions, all the values in the expression, all of them, especially the ones with x. And the one with the high, you look for the highest power of x that exists in it. In this case, the highest power of x is this one, x to the 4th power. So then, because that is the highest power of x, you divide the numerator and the denominator by that highest power of x. And that will cause all your expressions in x to be something over x. All right, so I'm going to divide firstly the numerator by x to the fourth and divide the denominator also by x to the fourth power, highest power of x. So then the limit becomes equal to, the limit becomes x tends to infinity. This, when I divide by x to the fourth, it becomes 2 over x minus, when I divide this by x to the fourth power, it becomes 4 over x cubed. When I divide this by x to the fourth power, it becomes 1 over x to the fourth power. That's why I know that this is going to be 0. And when you bring the limit on this one, and this one, they are going to be 0. Once you have x on the denominator, and I put infinity for it, it's going to become 0. So the whole numerator is going to become 0. But I want to see the denominator is going to become 0 as well, because 0 over 0 is undefined. So we're going to put this now. We're going to divide this also by the x to the fourth power and get 3. Plus divide this by x to the fourth power, we're going to get 1 over x squared. Divide this now by x to the fourth power and get minus 2 over x to the fourth power. Then now that I have that, I can apply the limit. So this then becomes equal. When I apply the limit, I don't write that back. This becomes 2 over infinity, which is 0. So remember, I tell the examiner here too, you know, that in all cases, 1 over infinity is equal to 0. So if you square it as 0, if you cube it as 0, anything over infinity raised to any power is just 0. Good. So this one, when I put the infinity there for the x, I'm getting 0, because 2 over infinity is 0. This one is also going to come 0, because I'm putting infinity on a here. So I'm going to subtract 0. And this one is also 0, because when I put the infinity on a here, I get 1 over infinity to the fourth, I get 0. So the answer looks like 0, but I have to make sure that the denominator also is not 0. Because the denominator becomes 0, then you're doing 0 over 0, which is undefined. Undefined, right? So let's see what the denominator becomes. So when I put this one, I get 3 over x to the fourth power. Oh, this remains 3. Sorry, I'm applying the limit. This remains 3. This becomes 0. So I'm adding a 0. And this becomes 0. So I'm subtracting a 0. So the result is 0 over 3, which is 0. That is it. See that? See that? All right, let me show you something now. Suppose instead, let's change, make like a small change on the same question, right? And see what would happen. So let me take this off. Let's say this was instead x cubed right here. This x to the fourth, let's say it was x cubed. So I'm going to change it. X cubed right here. Then x cubed would have been the highest power of x, right? X cubed would have been the highest power of x. So I'm taking a limit to infinity. I know that 1 over infinity equals 0. So I have to divide the numerator by the highest power of x, which is x cubed. The pen back a little thicker. Let's write this again. I'm going to divide the numerator. Oh, the pen is so thick. I can zoom up so much. Divide the numerator by the highest power of x, which is x cubed. And divide the denominator as well by the highest power of x this time, which is also x cubed. And I proceed to the division. So this becomes the limit as x tends to infinity. And this, when I divide it by x cubed, it becomes 2. Minus, when I divide this by x cubed, it becomes 4 over x squared. When I divide this by x cubed, it becomes 1 over x cubed. All over. When I divide this by x cubed, it becomes 3. When I divide this by x cubed, it becomes plus 1 over x. When you divide this by x cubed, you'll get minus 2 over x cubed. So I can now apply my limit. When I put my infinity here and there, each of these become 0. Each becomes 0. So I'm applying the limit, so equal to, this stays as a 2, minus this 0, minus this becomes a 0, plus this becomes a 0, over this stays a 3, this becomes a 0, so I'm adding 0, this becomes a 0, so I'm subtracting 0. So its final result is 2/3, if that was that. See that? Got it that?
Yes, sir.
So basically, whenever it's like approaching infinity, you basically just divided by the highest number x. That's
Yeah,
all.
to get them in 1 over x form. You want all the value to be 1 over x. You want all your terms to be either a value like this or some number over x raised to some power. Because all of these will become 0 when x tends to infinity. That's what you want. To get all your terms to look like this, you divide the numerator and the denominator by the highest power of x that you see in the whole expression. This one, when that changes to cube, the highest power anywhere is x cubed. So I'm going to divide the numerator and the denominator by x cubed. If you notice, all my terms become fractions with x on the denominator, except these. So all of these, this becomes 0, this is 0, this is 0, this is 0. Let's make another adjustment. Let's change this now to 2. Or since this is already have a square, let's change this to an x and see what happens. This already have a square. All right, so let me make that adjustment. Let's change this to just x. So I'm going to basically erase that power. So let's remove that power. Add over white. I use this. I remove this power. So there's no power on that now. That's just an x. Let's say that's what it is now. Let's see what the result is going to be. If we use that one. So when I look at it, the highest power of x is still x cubed. So at the end, I'm going to divide numerator by x cubed and divide the denominator so by x cubed. When I do that, it becomes a limit as x tends to infinity. This becomes 2. Divided by x cubed, it becomes a 2. Minus this becomes 4 over x squared. This becomes 1 over x. All over. This becomes 3 over x squared. This becomes 3 over x squared. This becomes 1 over x. And this becomes minus 2 over x. So what happens here now is that when I apply the limit, this becomes 0, this becomes 0, this becomes 0, this becomes 0, and that becomes 0. So the result is 2 minus 0 plus 0 over 0 plus 0 minus 0. So it becomes 2 over 0. And 2 over 0 is infinity. Now look here. You could also have a case where you also get negative infinity. Watch this now. Suppose instead this first term was a negative 2 cubed, for example. Then this would have been a negative 2. And this would have been a negative 2. And this would have been negative 2 over 0. Now this is negative infinity. See that? because it becomes negative 2 over 0. Or you can say it becomes negative 2 times 1 over 0. 1 over 0 is infinity. So negative 2 times infinity is just negative infinity. Or if you can leave the 2 up there and say it becomes negative 2 over 0, and that is negative infinity. So your answer can also be negative infinity. You have to be positive infinity. So you can have that as well. And you have to put that as the answer, negative infinity. So those are I just gave you some various ways that this could result with the same question. So we got the original case is 0. We get one where we're getting like a fraction 3 over 2. Getting one where we get infinity, positive infinity, and this one will show you can get negative infinity. So have all these possibilities that you can get. And sometimes you can look at it and know what you're gonna get, you know, as well, you know. You can look at it and know, you know. Let me show you, for example, you could actually know. It's because the highest power of the x is right here on the numerator, right there. I put in infinity there. It's like it's gonna overpower the denominator. Because in terms of power, it is so much bigger than the denominator in size. So like you know, set up become infinity and it's actually negative. But the best thing to do is to go through the process and make it work out itself. But sometimes you can look and know what's gonna happen. We even look at the original question here. So the x to the 4th power here on the denominator. Look on it. It's like when you plug in infinity in here, so it made the denominator so much bigger than the numerator. So it's like you divide in a small number on the numerator by a super large number. It is so super large, it becomes infinity. No, it becomes 0, I mean, it becomes 0. We divide a small number by a very large number because we plug infinity upon the 4th power here, so the denominator comes so big. The denominator is much larger than the numerator. So the numerator is a small number relative to the denominator by raising the infinity to a much higher power than the numerator. So a small number divided by a very large number becomes 0. We don't want to reason it out like that. We have a process of working it out, which is what I've just showed you, which is to multiply numerator and denominator by the highest power of x, because 1 over infinity is 0. And that is when you're doing a question where the limit is infinity, guys. This. I can also give you where the limit goes to negative infinity, you know. I can give you that, you know, negative infinity, you know. So if let me show you now. If the limit is to negative infinity, right? Let's do this one. And say the limit was to negative infinity. Let me change one of this. Let me change this to I'm gonna show you the limit was negative infinity. What the difference would that be? Let's change this to a cube. What was it? Let's leave it at the x and work this as negative infinity. Let's change this as well to negative infinity. This. So I made the limit go to negative infinity instead. You can have negative infinity as well. So let's change this to negative infinity. All right. So we're taking the limit to negative infinity. So all that is gonna mean is that 1 over infinity is still 0. 1 over negative infinity is also 0. But I can actually send you to negative infinity and it make a difference sometimes. You get me? Let me see if this one will make a difference. So I'm gonna divide numerator and denominator by the highest power of x still. So divide by divide by x cubed. Let's see what happens. Divide under here also by x cubed. There's some question where negative infinity make a difference. I just don't remember now exactly how and the circumstances, but you can do limit to negative infinity and it makes a difference. Believe me, it makes a difference. All right, makes a difference. Just as how the answer can come out to be negative infinity versus positive infinity, you can have a difference happening. All right, so this limit becomes the limit as x tends to negative infinity of, this becomes a 2. All right, let's make this a minus as well. Let's make this a minus. This right here, this is a minus 2. So this will become minus 2. No, it becomes minus 2. This will be the difference over minus 2 over x. Yeah, minus 2 over x. This way makes a difference. Good. Does it? No, it becomes minus 2. I divide by the x cubed, so it becomes minus 2. Minus, this becomes 4 over x squared. I'm kind of trying to think ahead. Trying to remember what the impact could be. 1 over x cubed. This one. All over. All over. This becomes just 3 over x squared plus this becomes 1 over x. This becomes minus 2 over x cubed. When I divide numerator and denominator by x cubed, that's what I get, right? That one, 1 over x cubed, 3 over x squared, and so on. And apply the negative infinity now. So this becomes equal to, this stays as a negative 2. It's just that all this is going to still be 0, right? Let's say be 0, so not really matter this time. I now remember the circumstance where negative infinity can make a difference. But may I tell you, there are circumstances when it makes a difference. It's a 0 as well. There are circumstances when it does make a difference. This becomes 0. 0. And this becomes 0. And this becomes 0. So it becomes negative 2 over 0. I don't remember the negative or the thing make a big difference, but that's what it is. This becomes 0. This becomes infinity. It becomes negative infinity. This becomes negative infinity. Still. Not infinity, negative infinity. That's what this becomes. If I remember, I'll tell you. If I remember, I'll tell you. I'll get an example when it make an impact. I does not remember, but I know it can make a difference when you put positive or negative infinity, depending on the question. I does not remember in the circumstances though. Because you see, this question is the first one I remember them setting in multiple years in pure maths. I tell you, I think from the new syllabus come out in 2011. This was the first time I set a question with those negative, with those infinity. They call the improper limits. Improper. Where you get infinity as answers and so on. All right. Which other question, Mr. Nathan? Just see my Karen, have any question? No, yeah, add maths and I do you Thursday. Karen, mic is off. Just see my Nathan, anything? Anything?
Sir,
What you say? Nathan, anything else?
sir, I don't really have anything right now in mind.
Well, all right. I'm gonna break then no? So be the case. We can get everything where you want done for tomorrow. Make sure when you come tomorrow, you know where you want. That's the point.
So,
Make sure you
wait,
know where you want. Yeah.
can do the 2022 one now. 5A.
2022, 5B.
5A, same limits now. Yeah.
Oh, 2022. All right. 2022. Pop. And if it's inside here, so somewhere should be right here. Watch the video for the thing there, yeah? For the 2023 paper. Read the questions them and watch the video. Watch the video. Some of the questions them are really, really very interesting, I tell you. Really, really interesting. You get me? Really, really interesting. Some of those questions. So, videos there, go and watch it. I sent it in the group. I need to be go online and chop it up into chapters so you can find questions easier. This one's straightforward. This is a normal regular limit. What means that if you plug in 2 here and here and the numerator, you get 0 over 0. Right? So but the concept is that x is approaching 2, so you don't quite reach 2 yet. So you're saying the x is not equal to 2. And so the x minus 2 is not equal to 0. And when something is not equal to 0, you can divide by it. Right? So if you can get x minus 2 factored out of the numerator and the denominator, then you're good to go. So that's what you want to do. Right? You want to get x minus 2 factored out so you can divide it. Right? So this limit becomes, I'm going to factorize x minus 2 out of it. It becomes the limit as x tends to 2. I'm factorizing the numerator, but I know that I must get x minus 2 out of it. What am I getting back? I'm getting back x plus 5. That is correct because this is 5x. This is minus 2x. They add to 3x. So those are the correct factors. Numerator, and then on the denominator, most of our x minus 2 as well. That's just how these questions are. And that is a x and a plus. No, x and a plus 3. Yeah, x plus 3. Because the far product is 3x and the near product is minus 2x. They add to the middle term of x. So that is it. And then now, what happens? You have gotten rid of your problem because you can now divide this by that. And you're left with these now. So now that you have gotten rid of your problem, which is these, but this is what was created the situation if you having 0 over 0 now. This x minus 2 factor. When you plug in the 2 there, it would have given you 0 over 0. By cancelling them out now, because they're not equal to 0 when you take in the limit, you can cancel them out. Because they're not yet 0. They're not 0. And so because you get rid of those, you can apply this 2 here and there now. So once you get rid of these, you can apply the 2 x equals 2 elsewhere in the expression. So it becomes equal to now. This becomes 2 plus 5. This becomes 2 plus 3, which is then 7 over 5. And that is it. So that is the question for you, this one. Anything else?
No, sir, that's it.
All right then. Well, I'll end it now, getting myself ready for tomorrow. Thought we'd go a little later, but it's all right. Carol, now you stay good? Not hearing from you. I wonder if you're gone. I don't see her name, but I don't know if she's there still. Carona? Oh, she's gone. Okay. There's just 2 left. All right, so for all right, I'll just end it now, okay?
Okay, sir. Tomorrow. Okay, sir.
All right, then, cool. All right. Okie dokie. Stop recording and see if I will get